Alright, so this is morning coffee. I think I'm gonna have to put this into morning coffee as well. Let's see here. This is gonna be a plus 20 dB because it's tuned for voice communication off the main microphone. Alright. Alright. So we're gonna talk about physics, guitars, and some car exhaust stuff. We're gonna start. We're gonna start with the physics. Okay. I wanted to talk about my perspective on how I view quantum vacuum pressure and how I intuitively I think, you know, I came to what my view is. It was not really like counterintuitive to me. It doesn't really make much sense that it is, I guess. But then that's me, See, like I don't really know. Like a lot of people have a lot of different thoughts and feelings on that. Okay, so it's like to me it feels pretty easy to understand it, but then, all right, let's explain it, and then maybe you can understand why I might think that. Okay. So quantum vacuum pressure to me is like a spring tension to a degree. So I first want to talk about a tube. We're going to talk about a tube. All right, because this is going to become far more relevant later on as to why quantum vacuum pressure makes sense. So it's like take a standard tube. You're going to bend some parts on the tube and you're going to cut some slots, all right, at one end and then the other. And so you take a tube, you get some flower petals bent inwards on one side, and then you cut in some slots right where those flower petals are that are bent in. And now, it's not going to fully cover the exhaust, in fact, part of the tube at all. But anyway, alright. And it should still flow through, because surface area wise, it's only capturing a small amount. Okay. But we have another tube over that tube, and then that's going to lead into some slots in those bent flower petals, scoops, that are heading with the direction of travel of air coming in to the tube. Okay. And the moment you start moving air through that, the intake side, of course, it's going to accelerate because it's getting pushed inwards towards where the center is. Then it sucks in air where those bent in scoops are, the flower petals. Then the air it's sucking in is the air in front of it that it wants to replace. Initially, it gets very, very fast because there's lower pressure now in front of it. And of course, there's an acceleration from that center as it travels out from the air that was there on out of the exhaust of the tube. So it makes it even lower pressure. It has a resistance to ultimately coming back in to a degree because it's already had momentum, airflow start to occur. So because it became lower pressure, it then rapidly wants to accelerate. Okay? Then, once it gets to that point where it's moving that air in and started to move already, that vacuum pressure, which is a spring tension like pressure, then flows into the flowing part already of the air intake. And then it rapidly accelerates that air as it joins in, creating it to be such that it has lower pressure again and can feed in more air from the intake. But we technically got more density inside the initial tube because there's more mass total by volume inside of the tube. Even if it is moving very fast, it is still ultimately now denser because it's recirculating that mass back in. It's just using a nice little clever trick of perceived pressures. Okay, and perceived pressures is the key word here, as information traveling through a wave, a sound wave. It's a pressure wave. All sound waves are pressure waves. That's what it is. So, once you understand that, then I want you to understand that, like, three-dimensional is not what you initially see it as because of Feynman's diagrams. Alright? You see it in a flat 2D world, and that's how you're initially taught, and that's not how I was taught, because I didn't get taught. I had to figure it out myself and intuitively come to an answer. I was already working on thermodynamics thanks to engines back in the day because I was really interested in them. And so it made sense to me that quantum vacuum pressure effectively would just affect where it had been. Time-wise here, entropedic stuff-wise here, it makes sense for it to affect its projected future sets of virtual and so on possibilities as pressures. And so it'll head back all the way to the beginning, the Big Bang. Why did it expand to begin? Well, there's got to be a reason for it. So that pressure creates movement, an initial movement, and then eventually it gets to inflation. Alright, so it's like it starts the initial movement, and it'll get to inflation because it has to rapidly expand. Alright, that expansion has to come from somewhere. And it's like, well, that expansion during that is cutting out a large amount of possibilities. It's not so statically ordered and fixed. It's now got distance and area for it to become more dynamic and have entropy, chaos, be a part of that, and the possibilities to gain back possibilities that it had lost. Then it loops back to a smaller degree, meaning slightly forward, the least resistance, the most resistance cut off, and it goes back to behind. That helps push. Like, we would view it as a superposition that then collapsed into this area of more likely possibility. And I'm like, yeah, no, probability, blah, blah, blah. Or you view it like you should, which is there's a door and a window of this wall, and then there was pressure sound wavies, and then while some got through the wall, most of them got through the open door and window because it's least resistant. Okay, and that's why, for me, quantum vacuum pressure always made sense. It was kind of easy to understand it. But also, I don't view it the way most particle physicists do. I view it as sound waves. I view it as kind of that, honestly. Like, there are fields and there are degrees of bunched up parts, higher density, resonating, spiky pressure waves inside of that field. That's all I'm viewing it as. That's it. Now, it doesn't necessarily have to go all the way back, okay, to the beginning of inflation, okay? So as it goes from the point where it starts to come out, and then it's producing a bunch of possibility projections, that then start to expand, it rapidly accelerates a lot of that. I mean, there's nothing there. You know what I mean? Like, from our view and perspective for what we are. So, inflation is a very weird one. Alright, so like the beginning, it'll start and then it'll go back, and then that's what starts inflation, and then as it goes forward, it'll go help inflation if it was there, and we see it, and then it can't do it back to inflation again. It just goes and stays with us as we go through our normal, everyday side of current existing phenomenon of physics. Alright? Which means we exist in a nice little place that has us, not needing that information going back quite as far. So we started off with like a little bit of movement, but that's because it's projected very far, goes back to as it's already started to move, it goes to a point where that information helps the movement and can create a degree, alright, of projected possibilities, more and least resistance. It's the pressure wave thing. It doesn't do inflation until inflation's already kind of happened. Alright, so Big Bang goes to nothing. It's just going to keep going. Inflation starts, it goes back to Big Bang, right? That helps movement. That one's a whole other situation as to why inflation's so intense, as to why ultimately we expanded so rapidly. Alright? All of a sudden we got a massive pressure jump behind us. Alright? So like that's why it's like do 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 boom. That energy came back in from what we projected from our initial movement during the Big Bang. Now, as inflation happens, then it's moving past a certain point of the intake part, alright? Then that starts to interactively and interferently perform intrapedic situational physics. Then that goes back towards inflation, and then there's a cutoff. You can't go back to the Big Bang. And then as it goes through, it'll go only to itself. The initial pressure jump has already happened. The initial acceleration from inflation has started to occur and sustain itself, just like we see with our observations. So, that's effectively all that really is to me. The best way to put it is like there's a convection current, there's a hot, dense place, and there's a place for it to go to. It initially starts, there was, to its view, nothing there. But that's not what that is. There's stuff there, there are fields there, there's so on, from both itself and what was. It then moves that, it then goes back to where it started, and then that will close off. It then gets changed into where it expands past the initial acceleration, an expansion into the inner tube. And then that stuff rapidly pushes with more mass, quotation marks there, it's density really, it's just faster. You see what I mean? Um, because it's, while accelerated, there's no mass in that stuff. So it then just helps create density and informational exchange. More resistive, because calculating past a certain number of nines is ridiculous, and least resistive. And then it heads that way. It then proceeds to accelerate. Fields are effectively like a version of filters. There's certain resonances and sizes of holes that the diaphragm has. The filter. There are many filters and many different shapes and distances. As it travels through, it then changes where and how much the diaphragm is pushed upon, stretched, how big the holes are, and so on. But that remains a constant. That looping of information for it to travel, for momentum to continue. Sometimes it can gain a little more, sometimes it loses. That's how I view quantum field theory, quantum mechanics, the Standard Model, and a lot of particle physics. I don't view it in probability, wave functional, this is a big ball fucking thing. I don't like that stuff. It's really weird. It's like, okay, sure, so there's a probability of existing in this blob. Whatever. I don't have to worry about that. You know what I worry about it as? It's this projected degree of resist, less resist, resonant pressure, and degree of vibration and exchange of informational vibration occurrences. It's all vibrations. It's like a bunch of vibrating stuff. Like literally, it's like there's this thing that stuck itself together and then it vibrated and it keeps sticking together as a result of its, vibrational situation. You know what I mean? It's like I have this thing that's vibrating like this. And outwardly in the fields that exist, it then influences that like a tonality. Now, it stuck itself together by vibrating the right way and hooking in with that informational field that it's hooked to and resonating with. And then stuck a bunch of them together, which that would be, now it's a quark. I know. Suffer. Yeah. Subplanck links are going to come into play. Tiny little particles. So I call them subparticles because particles are particles, like quarks, electrons, muons, that kind of thing. Like subparticles are like the things that make up like things that are massive compared to it. That's why it's like subplanck links are really weird, but they're fleeting little things, and then once you understand the scale, it's like astronomical units of scaling when you get into those areas of really small are basically what's going on. And so there's a huge distance and gap, and these little things are basically insanely hard to measure. And then you end up realizing why it's like, well, these little things that exist temporarily, ghostly, virtual, however you want to phrase it, but like they pop up and they're gone just to exchange information because it's a field to field, but then also it creates little spike waves, little jumps, little hops, little resonant, and then it sustains and then protrudes a given increase of vibration down the line, and then it'll do it again as it, of course, is moving. You know, the fraying, if you will, of the sound wave, the diffraction, like light, or diffusal, if you're thinking about it, like that fluidic, soupy air that we live in called our atmosphere. Now, the given material changes because there are different field fundamental forces, which is why sub-particle deals with fundamental force and field dynamics. That's right, fundamental force dynamics and field dynamics. That's what my math in my head that I do, and what I can view, because I view it all the way down to that, all the way up to universe kind of levels of stuff. And that's why when I say like I can imagine that stuff, it's a lot different. I actually do that, and other people, I guess, never really got that part, you know, for themselves. Like they learned the math, they learned like, you know, concepts, but they didn't learn that part, and that's kind of what I had to learn to be able to understand any of the things that they were saying, because that's how that works for me in my mind. Like I didn't get taught at school. I had to learn this somehow. I had to brute force it. I didn't look up things online. They said that this is what they think. So I was like, well, fucking, how would that work? And then I had to figure it all out eventually. Because you have to remember, it's like, oh yeah, no. When you think, I looked up something online, the answer usually almost always turns into the same fucking thing. No, and mostly because I have a hard time reading, to me, very uninteresting, dry pages of things. It's like really hard for me to focus on that. So it's like, well, imagination land exists, so let's figure it out. They said it's this, let's do it. Let's try and figure out what the hell they came to for a conclusion, and how it had to have happened for them to get there. And so I said about like, why the hell do they think with screens? No, the guy probably was like do do do, and then it'd be like this, and then he was probably walking along, and it would have snapped in his head. And what do you know? That's exactly what happened. And that's Feynman. Schrodinger is like, well, you know, we had this and that, and then the dark war of this cold and this fucking biggie boom booms. And it's like, well, they imagine it like this, and so then it's like, probably they would have come, and, but you know, yep, that's a superposition to him. Meanwhile, me, I'm like, it's just staying still-ish. With less around it that can interact. To its perspective, though, it definitely knows where it is. Now, we can't determine that, because we can't observe that. We want it to be separated from all of our versions of how we glean information. Which puts it to them, kind of like the spy games, in this superposition. They're in the position where they're above others. They can then take advantage of our games. Superposition. And how they came about it, what do you know? It still works, though. I was like, well, this is kind of dumb, though. That's not how that works. It's still there. It's just in a pocket. are like a bunch of acoustic waves that effectively keep it fed as a continuation wave that it is in this kind of area, like wave tweezers. That's all it is. It's like, ooh, I'll skip around, I'll curve, I'll do this, blah, blah, blah. And it's like, it basically just stays here. It's just here now. Just doing its thing. Just staying here. It's just kind of, you know, traveling the same speed that we are around this star, curving also with the rotation of our Earth. There's some jostling though, but for what it's worth, can't get around those waves. Gravitational waves suddenly come up. Because they have talks. They have talks behind closed doors. The other astrophysicists, quantum physicists, debating how it all works, the math and science behind it all. Next thing you know, gravitational waves might be a thing. Didn't even know what the hell that was. Oh, but gravity waves. Huh, that makes sense. Space-time Einstein comes around. What's up? Basic stuff to me. You know what I mean? Like, because that's how I imagined it to begin with. Like lepton, septon, it's just like, this is a given wave that has a given influence like this because it vibrates like that and oscillates like these things, has this given input information for these given fields with this given energy for these given moments with this amount of likelihood effect thanks to the influence inwards and outwards for canceling out to direct connect. It all kind of came about after a while. I was like, this seems like a lot of fucking math for basically saying nothing other than the same thing that they already figured out before. Like, I'm not even kidding. It's like, so thermodynamics. No one likes that guy, Stirling? How come no one likes Stirling? How come no one likes fluid dynamics? It's effectively a chaos. You have chaos theory mathematics. What's the problem here? Well, we don't know what the initial start was. You don't need to. You can glean that information over time. That's chaos theory mathematics. If you want to more accurately work backwards, then you can do that as you proceed forwards. Like you're doing already. Once you have that algorithm, where's that one? It turns out they already have several versions of those things. I started looking at them strangely, like, why are you still doing this? You already have everything that solves this. Turns out they didn't have causal set theory yet. I was like, what the fuck? How do you not have this? Causal set theory might as well just be called, like, fucking entropy, but with, like, slightly extra as math. Because if you look at the slightly extra, it then turns into, we put in causal set theory chaos, but with slight changes. With the entropy. They won't know. I'm like, it's literally a domino. It's a program. It's this goes down to that goes down to this, that goes down to that. And you have these degrees of less resistance, while these things over here still impart a given energy because it still bleeds that energy, but then that will still have to go back. It still tried, technically speaking, to impart that energy over there, but didn't get anywhere because it doesn't have enough. So then it goes backwards, and it feeds itself in. Or it goes off to another particle, or atom, or something else, and then it'll put energy into that. And then you look at it like, well, it's basically just a fucking three-dimensional thing working. Why do you have, like, a bunch of little tiny flat things? Why don't you use it like it should be used as? A three-dimensional thing that moves over time in a 4D aspect that then influences itself both inwardly and outwardly. And you just piece together the right little number of pieces and then move it forward. Which is what I do all the time in my math and my imagination. So it's like you have all the pieces to basically run this really well. Why don't you just do that? But they had that back during Einstein's time, for what it was worth. That's why I was like kind of weirded out. I was like, this is a big like kit and caboodle of people that are real. I'm smarter than thou. I'm bigger. Ego. So on. So on. So on. And it came from the 1800s of people discovering electricity and the fields, the electromagnetic fields that came with it. Well, they didn't discover, they already had it, but it was like they finally started using it more and understanding it more is a better way to put it. And people wrote math, and then next thing you know, right? Big, but it's like, it's still the same pressure thing. Nothing changed. Stirling was right. It's just fluid dynamics and pressures. It's literally all it is. It's thermodynamics with fluid dynamics. Some chaos theory of mathematics. I mean it. That's literally all it is. Like everything that they have so far ever put out, I'm like, that's all I'm seeing. Their descriptor of this other fucking effect, it's another version of that. Quantum field theory basically went boop, 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 boom. I mean it. This is like, there's some of it that's in there that's good, but then it turned into like, you already have this. And also, that's not describing what you're seeing, really. At least not over here, here, you know, I just started looking at them all. I was like, you're all trying to come up with something, and I don't know what the hell this is. Because it seems like the simplest answer is always going to work. These are the thermodynamics with fluid dynamics. This is basic acoustic stuff. None of this is very difficult. You've had this forever. You had the math already done, and you don't account in that math for the variables, you know, the numbers you're using here, for your observations being off. Thanks to that degree of lack of willing to do the setup. You know what I mean? It's like, no. You started with it's a hard thing. But it's not. You started also with this influence not being accounted for, and you moved forward with that. And you started with these variables not being a factor. And how you sense and detect your data. And then you interpreted the data. Like every step of the way, I started getting pissed off. I was like, none of these numbers are really something useful after a bit here. I don't know whether they get this after a bit, but like, it's easy enough to do that. To account for some of this. But like, you know, really making a strong box and then shining the, you know, and then like, here's some, you know, it's like, but, okay, let me just posit this one real fast. Alright, you understand that, you know, the little three-dimensional cube I talk about, and as it moves forward, yeah, vacuum pressure. This moved over here, it can move in there. But that moving forward over there can loop backwards to where it was moved, but also it can create pressure as it moves forward to the thing in front. These tiny little instances of this thing not being, then all of a sudden acts like a virtual. You have never really seen beyond the quantum foam zone. That's why I call it potential land. Quantum foam zone is nothing compared to that area. That's why people tend to conflate and confuse that being the same, and it's not in the slightest. Like, there exists in that way deeper fucking parts. And the evidence presents itself wonderfully with all the data you already have. That's not even getting into the inaccuracies. It's like, well, why didn't you think about all these given fields and how they situate themselves with this resonance and this layering as a puzzle piece to this degree of increased likelihood in your version of math? It's pressure changes that are consistent like this, that are a constant variable that you can now affect and denoise, and then further denoise from the data that you receive. So I made a box. I made something kind of less influenced from this stuff but none of this stuff. None of it, huh? No. No. Then, on top of that, you're not taking into account that vacuum that you're creating as things are around trying to make it, in your words, stable and ordered. How the fuck do you figure? You have the math already that showcases if you want to have, like, measurement of time, you have to create more entropy to do that. Everything around your little sensors are now less accurate by having yourself do this. You should account for that, and you're not. So, that one gets pretty annoying after a while, and you don't do an order of sequence of events that you time specifically with knowledge that it should be incredibly likely and consistently this that you're doing to make this thing that you're trying to measure happen for all of your sensors, all your field dynamics, or your electricity changes. They're getting in, they're trying to. They're angry. Yeah, well, they would be, generally speaking. It's the standard problem of, like, well, I don't like this person that's not as smart, and all these things sounding smart and saying things that showcase that yeah, we didn't do, and this is a major fatal flaw and mistake in our process, and we've been doing it for decades and decades and decades, and we built up so much math based on it. You had to basically throw it the hell out. Yeah. All because of various ego, fame, fortune, so on. It's like, you can't use any of it. This is essentially so inaccurate, you can't actually use that idea as being reasonable. Now, you're going to consistently get these types of results, yes, but the moment you move somewhere else, You don't. You're in a nice little Goldilocks area. Be next to a neutron star. I have a higher radiation planet. Well, you think that means nothing? The amount of difference in quantum tunnel, the curvature of space-time, well, for you, doesn't mean much. On that scale, it'll mean a lot. Particles of distance will mean a massive change in gravity. There's no such thing as static on that end. What you have built up for math doesn't take in any way into account for any of this, which is bad. We'll move forward because it turns into... Let's get into this one. Really fast. Field dynamics are not what you're trying to measure. You're not trying to measure the acoustic spike waves. You're trying to measure results from an acoustic spike wave to a given poorly set up sensor that has to send data through a massive array of likelihood noise before it finally gets stored, as it does something to a very highly specified setup of fields that make almost no sense because that field isn't really that field. See what I mean? Talking like basic kind of superposition, but like it's taking energy from that to remain where it is and doing what it does. The field that you believe it's going to rest on. That makes it colder and less interactive and has changed it. They don't really exist like that much. And then it's taking in information from the things that are trying to keep it as it is wanted to be kept by you. They propagate outwards. You can't active noise cancel like that because you're not doing it right. You're not maintaining the field that you want it to be in with that active noise cancel. You're not keeping the correct energy. You're not keeping the correct state of that thing. You're not really doing anything with it other than, it's kind of, pretty much there. It's like outside influence is so significant. You didn't even think about your own. let's get into like the fleeting nature of some of those degrees of fields that will exist briefly and then decay so quickly that you're never going to get them from a particle smasher. Makes no sense. It doesn't matter how much more energy you put into it or how fast they travel. You have very little there that you really could see if you were to do it a little bit better and not smash shit. It's influencing various degrees of energy input and highly specified ordered resonances that project in a given area, kind of like a focusing lens for a laser, a given field dynamic change that is in the sub-particle range, allowing for an increase or decrease of a given information exchange. Already warmed up to your entire particle smashing bullshit. That's all I have to do to ultimately showcase that my experiment would be successful, and I could find many different subparticles, particles, and field dynamics that exist faster than the speed of light. Brief and travel quite quickly. Granted, they don't have much mass, in fact, at all. They'd be light in a different way because, of course, it's sticking around, but then it decays quite fast, which would be radiation, and it's definitely a different type of nuclear to electromagnetic to mass, and so on. Why smash when I can just influence and get the results? If it is like this, then if I do it that way, it should do it like this. Proceed to get the results. Hey, what do you know? It did do that. It's the same as anything else. You want electricity to do this, you do this, you input some electricity. Oh, what do you know? It did do that. Hey, I pushed down on a pedal crank. I want the wheel over there. Oh, it did do that. Do you see why I look at you and I go, you guys are really all looking at the wrong thing here. Y'all got so trapped into this idea, this perspective, that's it. And you never went outside of that. You think you don't try, you definitely try. You think you're creative, you're not very creative, you don't think outside that box. You think you're intuitive, you're not intuitive. You think you don't teach to a specific type of way of thinking, gatekeeping. But that's exactly what you do. Right. Power exhaust stuff. Let's do that one next. Okay. This one becomes pretty easy as I just kind of explained it a little bit. But this one's more about how I cheaply-ish create and fabricate. This is a concept idea, not something I've done, but it will work just fine. A much stronger, much lighter, and much more easily put together exhaust system. So, we get a standard mild steel, alright, tube for the ports of the exhaust of a car. Now, we want the inside diameter to be what it is and the outside diameter to be what it is. We have a bend that we need to accomplish. We have the thread did, the outside diameter and the inside diameter, where the bend is going to occur. Now, this one's a bit tricky, but stay with me. Okay. This is going to go into a wider area, kind of looking like a two-stroke. Starts small, gets wide, goes back to small. Within it, on the small, on the inside diameter, where the majority of the curve is, there are indents. On the outside, there are overhangs with grooves, so vertical lines that travel with that. It's all meant to help airflow, yeah. But hold your horses and wait. So it's nothing to do with that, but this is the reason why I do it. It's a larger diameter for a reason. It helps expand and it helps it curve. Gives it time and space to do it. Now, the thread, alright, we thread it, but this is in a bead blast, whatever chamber, you buy it, and you suck out all the air after you silicone caulk and all this other shit to basically keep it airtight. So you suck out all the air, you thread it. You're not going to use any Loctite or anything like that. None of that's going on. You just put it together. Okay? Then, we're going to have a positive and a negative. There's going to be a ring, negative, in the inside diameter of the initial tube. There's a positive half, okay, so hemisphere, circle. You're then going to walk it, and these are small, and then the inside diameter, negative, is a conductive diamond-like carbon to regular, like copper or something. Negative electrode. Alright, whatever you want to call it. I never really gave a shit about terms. It's a negative terminal. It's whatever. Now, that negative terminal has a inside diameter that you are looking to maintain jacket that you can slide forward. Alright? And it can scrunch. Right? So, as you put the positive over on one side, it then heats up, right? But throw all that out, because you're not going to do that right now. What? Yeah. Take it out. I'm just letting you know about that ahead of time. We're going to go into a bath of chromium and molybdenum liquid. We're going to electroplate. That's right, electroplate. It'll be something that you'll understand why you're going to do this later. So, it's already tightened. We're not going to do any of this O-ring crap. But you know what? Since you're hey, don't interrupt. You're electroplating. It's going to try and get into the threads, but it's not really about getting into the threads. We're only going to do micron amount of this shit. This is a whole other thing to do with heat transfer. And I'll explain that later. So, you electroplate it, you got your microns of amount plated. You get it back into the vacuum chamber. You then electrically resistively weld. You're going to heat the shit out of this fucker. But because it's in a vacuum and it's not going to touch anything, because you don't want it to touch anything, you're then going to slowly walk the weld from front to rear towards the middle, and then from the middle up and then back down. Alright, at top to bottom, because it's hemisphere. Now, it's still going to be very hot, so you're going to put it in the jacket. That'll cool it rapidly, but it keeps it at the right internal diameter. Now, as a result of that, it stresses the threads. They're mild steel, remember? They also weld it. Microcrystalline structures start happening as they tension and stretch against each other and weld it. As it cools, and then it pulls heat in and then also out as that warms back up. It then both stretches and twists internally. Kind of like you're bending sheet steel, it now becomes stiffer, but is using internal stresses during the welding process. The electroplate for this is very consistently, this is harder and brittle at the outside, and then as it stretches, it becomes more porous, and it seeps further in, and then twists and torsions, tensions, making the microcrystalline structure better in those areas of weld. It's a full weld, but also happens to be stronger, kind of like it's a type of hardened tempered steel. It'll stretch and it'll bend because it has brittle, and then next to it it has regular mild. Now, it will cool very slowly because it's in a vacuum. Once it has heated up the jacket, which that's another ceramic, so you don't want it to actually stick to it, which is another reason why we have the electroplate, chromium and molybdenum. They don't tend to stick to that. Now, as a result of that, it then becomes a fully welded piece with no real seams. Much structurally stronger, which is a good thing. You're going to want that. But also you got in that area the seepage. And it stayed the same in terms of its internal diameter and the straightness that you're looking for. It's going to bend and move around regardless. Now, this is where we get a canister that's already there, and you already have electrodes and all this. There's a powder coat, and then there's a negative. You already have a negative. First, you wrap the outside diameter with Kevlar. While you also powder coat to make sure that it's getting in between the Kevlar and the steel every wrap until it eventually fully covers the wrap too on the outside, and the inside is essentially just pour it in and have it come out. Make sure it coats evenly, doesn't over coat any particular place, which that one's the really difficult-ish part. So the canister, and then it's some lots of shaking, okay, kind of a thing, and it's touch the electrode, don't touch the electrode, touch the electrode, don't touch the electrode. It's a lot of back and forth in certain areas as you try and get it to stick, and then you're done after that. Then you have to wait for it to cure. Well, guess what? It's in a vacuum. You have an electrode and a positive and negative electrode. Electrically resistive heating is just fine for steel. So get to work on that one. Get it warm. Do it in sections. Make sure you don't overheat. let it bake, then cool off slowly. And let it bake again in an oven, and then let it cool off as needed, necessary, sure, whatever, interrupters. Now we get the regular mild steel, sheet steel, that we're just going to bend around this. Make sure there's a hole, you'll weld it, so that way you have a little vacuum plug. You're going to coat the inside diameter in your powder coat, the outside as well, and then you're going to do another wrap of Kevlar. One-way valve is all you need from air inside to outside. You're going to make another one of those to go over that one. And this is going to have a different area where that's going to poke through. And you can do a third and final one. And that one, you're going to finally do all the same things and be done. It's threaded, and then you weld it the same way. You don't need any electroplates for those, though, which is nice. Now, we have a triple wall vacuum, powder coat, which makes also it more insulative, with a insulative Kevlar material. As we suck out all the air, as is already in a vacuum anyways, but if you happen to, with the pressure gauges, alright, that you can put into it, but I don't, but I still have the tubes. Just FYI, yeah, there's just tubes that have a fucking one-way valve, so they're tubes. I then hook them up to a vacuum pressure gauge, and then try and suck out the air, and then see if it holds. Now I've tested it, now I'm done. It's good to go, and I don't have to worry. Now, because there are multiple, not one, multiple ports on average for most engines, that means this becomes a blocky by the time you get to the third vacuum covering bent sheet steel. Because you have a lot of resistance to that heat traveling, as there's insulation inside, outside, and then not much for air for it to transfer through, except for where ultimately it's connected, which in this instance is multiple powder coats and multiple Kevlar wrappings. So it tends to heat soak a lot less and become more efficient at delivering its heat to wherever it needs to go for the exhaust. In this instance, it's turbines. I like turbos and I like superchargers combined together. I hate the types of turbines that they use, so I always tend to go with a longer and resultively more quickly air-flowing type of turbine. It's more weight, sure, but at the same time, it's more efficient and more consistent, because all of those tubes go into a bunch of these little vacuum spring areas. So it's like I suck out air, and then that is essentially a teardrop shaped valve. It gets pushed out, it's fairly low spring pressure, and then it goes through, rapidly accelerates, it's hot, and then it'll close down as it produces a lower pressure, and it's all about tuning that spring rate such that it fully exhausts the majority of its material, meaning its combusted gases, and then it closes. And it can't go back in. And since every single tube has this, it then means it's a lot harder for that pressure to go back into the tubes, and because now it has way less pressure in the exhaust tube, and it's hotter, it retains the heat inside of that steel tube that has a coating on the inside with a chromium molybdenum electroplating, which are very high heat resistant. It then means it tends to retain its heat in the tube and then dumps it into whatever gas might be there, making a stronger vacuum and a higher degree of scavenge effect from that given exhaust, as it'll go into the tube rapidly and then it can't go back in to any of the other ones. Now, there's a degree of initial pressure from the spring pressure that it has to overcome, but that's startup. And then as it gets hotter, it gets more and more efficient at removing exhaust faster and faster and faster, as it will accelerate faster and faster and faster, and it uses as a stored vacuum energy, vacuum pressure in this instance, of spring pressure. Yoink! Get out of there, exhaust. Then, because it's hotter and it accelerated faster and it retained more of its energy, it goes to a more efficient turbine. Which will still be a higher flowing turbine, but because it's longer and it's more efficient, it should capture more of the energy, while there's less back pressure overall, because of course it never sees that there's a turbine there. It means I can get away with much higher degrees of pressure for that turbine, meaning bigger, bitier blade angles. Typically the diamond shape tends to come to mind, but I can't really use that, so I tend to use the teardrop shape. Starts small, gets wide, starts to head back towards a small, and then it's done. Kind of stuff. Typically, it's just an easier way to get it done overall. I've tried to do the from the side, and then it is hourglassed outwards, but then having to have that come back towards the center is annoying, and I don't like it. So most of mine are all elongated types of things. Makes it easier also for the axle, typically, that you need to have, that I add together. I like the idea of using vacuum axles, but most people don't like them. They're effectively think of it like a chain belt. So it's gear here, gear there, this degree of in part, then this degree of in part, and because there's a tube in between, but the tube is static, but because it's sealed, that then means because there's nothing there, but there's high pressures on one side and the other side, it then transfers that energy very efficiently with less loss to mass that you have to move. But most people tend to not like them for some reason, so they don't really quite understand how that would work. So, regular axles, I guess. But that's always the same thing for the venerator. So I call it a venerator. All it is a CVT. You know what I mean? It's two little cones, and then it starts off wide, the widest it can go, because that's the spring during startup. So it'll go really wide, and the supercharger doesn't really need to be very parasitically there. Okay, but then it very quickly goes down to the smallest, and then it'll use weights to slowly open up and resist the spring pressure that's there. So, in this instance, when it turns off, the spring pressure goes back to opening it up to being a wider area. Then weights then are going to slowly reduce that ability for it to remain open. Alright, I have to describe that one really quickly. Okay? So, there's a spring, alright? Make sure it's as close as possible. Okay? Then that spring, once it starts spinning, disconnects like a clutch. Then the weights are very close, and then that other spring, because it disconnects that way, same spring, but because at a clutch it disconnected from being at its connected point that keeps it open as a result of the spring. Closed. Alright, so that way it's as large of a gear ratio as possible. It then connects and snaps it in once it starts spinning to its most open position. And then it's at a much smaller gear ratio that will slowly, because of the weights, make it come back in and then go back to a wider position. The reason why this is a good thing is because during startup it has the highest degree of parasitic loss, and you don't really want that. And once it gets going during idle, it situates itself at a good gear ratio for you to use, for you to get the correct PSI that you're looking for as forced induction. This is a compressor. Okay? Now, that's really good as a way to get around certain parasitic losses. It then slowly, as RPM goes up, changes its gearing. But because its RPM is going up, because the gearing ratio changed, it maintains a more consistent PSI, and the parasitic loss gets lowered. Alright? There is a certain point where the turbine has spun fast enough to then engage, like a torque coupler, effectively, into that system with that axle. So it's a coupler, but then it's going to kind of be a little not engaging until it eventually engages at the right RPM. It then runs the compressor. This generator area is to be either with a solenoid or with the correct weights to be disconnected once that happens. I use a mechanical and solenoid system. Once the engagement of the RPM, which is what we're looking for from that turbine, has occurred, that disengages mechanically the supercharger pulley system and instead starts driving the serpentine belt to make sure it runs at the correct speed that we're looking for. Top end, you go from low up to like this particular point of RPM because you don't want to go above that. Then it dumps all of the rest of it into a torque converter. In the rear, effectively. It's going to add it to the crankshaft. Now, there's a degree of loss, sure, but it's an easier system than like trying to get a circuit design and a generator like MGUK instead of just dumping it right into the crankshaft. At that very top end, You want that work energy directly there. You don't want to have to time anything. You don't want to have to do anything. So it's like that work energy gets immediately dumped in from that turbine, but we can only capture so much. Okay? But now it can freely spin as fast as it can darn well please. Doesn't matter how fast it's going to spin. I want that to engage that work energy. Now, is it 35% efficient? I would hope so, because it's a high gas system, but then that's what it is. You know, not much I can really do about it. But that's what that is, and we're talking a good amount of extra torque and horsepower. The parasitic loss we see at the low end, that's fine, because I don't really want horsepower, I want torque. Torque is all forced induction, alright? That's kind of what that turns into. It's like forced induction is torque at low end RPM. Once it gets up to high RPM, torque and parasitic loss gets added. So torque gets added in, parasitic loss gets removed. I have a higher degree of torque at the low end that I want for getting out of turns, and then at those really upper high end speeds and RPMs for the engine, I have more torque and more RPM, consequently I can run it. So it's more efficient. For racing parameters, or for me, I run small with a tiny engine and big car engine bay that give much more efficiency to weight and torque amount. That's energy captured to energy used. Weight is the enemy for efficiency of any vehicle. If I can make a smaller engine perform like a much larger engine, then I manage to gain a lot of energy efficiency to work energy. I'll use less fuel even though I'm at a higher RPM. To maintain the torque. It's a way to get around the RPM problem of smaller engines. Granted, I also have a bunch of other types of engines that basically say, yeah, you thought, but not really. Like, I love my toroidals. Like, they're effectively like, look, this is a foot-long connecting rod. It's only 49 cc's. And then I have, like, effectively 2 more foot-long, like, these torque converters that are around the connecting rods that are hollow, that allow for air, and then there's, like, it doesn't matter. Point is, go through that one, the toroidal engine thing. Alright? But, like, that's how, like, it makes with a clutch, the movement of that fluid, which the fluid is also cooled, whole thing, the coolant thing, genuinely just don't even involve the idea that you're right about something, because, like, I addressed it in that. But what it means is fluid flow, and because it's stiff, if you don't know, it's a non-compressible fluid, right? But as it changes its direction, it acts like a tensioned rod, but it also moves. And so it turns into a clutch torque converter that happens to transfer its energy to the axle, that has a degree of tension. It's always there added. So it's like a torque converter. It's not a torque converter. You can't call it a torque converter because it doesn't make anything accelerate to produce greater degrees of torque. It's a leverage increaser. It takes the leverage from these two other areas. It's all one, technically speaking, but they're not really. You know what I mean? But it goes up, it goes down a little bit, and then in the middle it goes back up, and it goes down all the way to the bottom, and then it goes up, and it goes down a little bit, and then back down to the bottom, and it goes up, and it goes up, and so it creates that kind of a style. But they're separated on both sides of the connecting rods, which aren't really connecting rods, but I'm going to move on. So they're more air centripetal force compressors. And there's already another compressor in the front. Whole bunch of stuff like that. But they're effectively donut shapes. They're literally that. Yeah, they're toroidal. So it's like it's a tube, and then there's some like bumps in this tube on this side, and then they rotate counterly to each other. Then there's a hollow axle that then delivers to a solid main axle at the rear. There's some clutches and some gears, and then they counter rotate as they compress air, inject the air. So I don't really need these valves that you use. Those valves are weird to me. It turns into, in this area of rotation, it then opens. Or, to put it another way, those things have to be in a housing. There are bearings there, because it has to fit within this little, area that we carve on the other side, and then this one protrudes in it, but then there's the correct gapping, right, that creates this has become compression zone. So like air is already here, inject fuel where the little gapping bump is, and now I have that spark right there. It squeezes it as it moves, and then it has a rapid expanding hotter gas. It then expands and does the doing the perform work energy thing. It then eventually exposes another gap that goes off to port area for exhaust coming out the outsides. So, the bearing acts like a bump stop that allows for, in that area, the fuel to come out and the air to come out, and then it also exposes a open area for the exhaust, which is, as it moves it does this, but then it also happens to shift it such that it can dynamically alter how much exhaust is increased, kind of thing. RPM isn't really what creates the compression. It has a compressor coming in before it gets into that. That just extra helps that compression, and then it has a fluid. No. I want to talk about the fluid, but the fluid's already known. It has a water cooling fluid thing that goes through that. So it's like, think like for this compressor, it's like a bullet nose that then goes off like a scramjet to the sides, like a turbine. And then it's like, there's effectively a big dead zone there. And I was like, I don't like that dead zone. So you know what that dead zone is? Because I need stators there anyways. Well, we'll talk about it. So as the air goes through into the tube, the hollow axle, which is a tube outside, that's the rotating, and then this one is the tube that's connected, and then that has the correct bearings and clutches to allow for all this to work. Not even going to get into that. Then it acts like a torque converter as it travels to the rear. It then has like a little parabolic spike, goes up and then over. So it goes in and then out and then back towards, like a torque converter. The arms are shaped such that they're airflow, like turbines. So they push it through. There's a little stator in the center, and then another one pushes it again, for this given torque energy here. So, stators allow for more efficiency of the two. It doesn't sound insanely violent as it goes through, and it is also water cooled. That's why those are there. Those are water cooling vanes, stators that go off and then go back towards the air to water intercooler heat exchanger. And then they get pumped back in. Cold to where the initial area is for the ramjet style funnel. And then that has a bunch of, little areas for as a radiator to help cool the outside, but then as it goes towards the compressor, it is a couple bullet shapes without trailing little tails, and then they bifurcate until they get into the compressor area. That's another heat exchanger condenser. Then it goes through the jacket of that, and then it goes off into where the cooler is for the stators. And then it travels into the axle, helping cool it in the tube, and then also it goes up to the stators in the middle, and then back out. Now, the air got pumped into that dead zone, so now you know. You probably figured that out with the stators that I have there. But now you also know why those stators are there. And why it has a much greater compression ratio than you think, and why I don't give a fuck about what fuel I use. And why it's much more cooled than you believe, and much more efficient as a result with compression than the average engine. Because coolant gets moved up thanks to the rotation of the engine. It's a water pump in its own right. It's the axle. Yep. And then the top. There you go. You got it. The toroidal donut part. Also pump. So. Just separated. Right, it only needs to go to one side. This is pumping up. This is then going to take that as it moves in between, and then it curves it off and sucks it out towards the cooler, the radiator, heat exchanger, intercooler, whatever. Never even gets near the exhaust, turns out. Maybe if somebody listened to that video, they would have known that. Same thing with the hydraulic fluid that is the lubricant as well that I use. There's very specific areas where the exhaust will happen. Now, while I do have 12 rods here, that means I can constantly balance that area for exhaust ports. And another reason why the dynamic exhaust port openings can happen with the bearings. So that way it's always timed to perfectly exhaust and never interfere with itself. And act as a nice little, this is flowing really fast and it's hot and I sealed it and it can't go through, but guess what? This temporarily saw that as now being a much lower pressure and zoom. Scavenge effect. Right. Of course. Exactly. The valve cover there, which is really very much valve cover, it's an exhaust cover area for the housing thing. Doesn't really matter. Point is, that is a turbine. It goes from the outside center in, or the center in towards outsides. There's a tube, there's another tube, there's another tube. Stators are hollow, tube rotates, it pushes that tube, that pushes another tube, and then the housing, of course, is static. Those two combine, axle on both sides, goes to compressor, compressor tied to axle, which happens to be another version of generator, with spring and clutch setup. Then also fluid go burr to axle and rear that is connected to all of this. I then have from that side vertical to straight largers, big long ones, big huge diameter. Okay. That then combine into singular area as they are pointed downwards to join in this area. That is where the exhausts 2 into 1 go to, as standard for the actual engine. The engine combines both 2 into 1. I've already gotten so much of the heat and pressure at that point that I just don't care. That's all a bunch of work energy too that I added into it. It's very compact, yes. Some people wanted to do the 3, so it's one thing rotating, 2 of them are rotating the same direction, 1 is counter-rotating. I found is it's not balanced in terms of weight, so it's not very easy to use that. It's not technically more efficient, and there's more complicated parts to make it happen. It's balanced though, but then so is mine too. So I don't know. You can use it though, but it's better to like do 4 instead of 3. So it's like 2, 4, 6 evens, much better. So 2 is more than good enough though. Like for what it's worth, I have a bunch of leverage, which is how I'm getting way more torque. Like it's a foot, but then it's like I technically have 3 feet, but it's not really 3 feet because losses and all that. So that's not going to happen. So it's really just going to be like 1.8 feet more, roughly, than the foot that I initially started with. And I have 12 of them, but not really. But then it's like I kind of do. You know what I mean? Tends to be that type of thing. It has a higher RPM, but then I can dynamically add in the type of fuel load, kind of like a diesel, but then it can also be very much burnt into that cylinder and then squeezed and then added to as a lean mixture, which creates a detonation velocity gas escaping, and that little, that gap that I talk about, it's a wide to small little thing to back to wide. It accelerates and also burns more as it does this, which is a rocket exhaust. And it's cooled. Those bumps are cooled, by the way. There's hydraulic fluid coolant, because that needs to rest on a bearing somehow and lubricate itself, so it's gonna be just fine. There's a radiator, yeah. Very highly efficient. Yes. Very highly efficient. Got 12 of them going off at any given time, and then I have a space at the top and bottom dead centers that I don't really need to burn anything. Or if I want to burn things, that makes it more efficient, as it'll take longer duration before it'll exhaust. So For what it's worth, it turned into a multiple compressor. So it's like I compress, I burn, that burn then gets very lean, and then I burn it again as it goes through, and then I burn it again as it goes through, and then I burn it again as I go through, and then I burn it again, and then I go from one rocket into another rocket into another rocket into another rocket, and then if I really want to get crazy, I'll add another rocket. I could get totally 6 rockets going for both sides, and then it'll just exhaust it. But what I found, if I do it the right way, I don't need to do that. I really only do about 2 rockets, so that way I can exhaust and thrust more. So I thrust while I'm thrusting, so I can thrust some more thrust. Because yo dog, I heard you like thrust. I'm going to use the exhaust at the end once I start it to then really create more thrust, okay? Because I can compress while I compress, and thrusting while I thrust, giving me more torqueys with my leverage. Because building up, exponentially increasing, is what we call that in the business of thermodynamics. It's using a degree of start to then be built up into more, to then be built up into even more. Because I can set them up to have already in that chamber a little more air. And then as it squeezes, I then start that process, and it exhausts here, and then it'll rapidly accelerate as it finally has an exhaust, and then I can add in fuel at the right areas, at the right time, and then it rapidly sucks in air from the start as it's already moving and expanding, getting smaller, and then dramatically increases the amount of velocity of the airflow and thrust captured. And then I can do it more and more and more and more as it'll start the process again already as it's already doing it, and then it'll just rotate it constantly as it does this, doing it constantly, never-endingly, as never-ending amounts of oscillative thrust. So starts here, and then as these collapse, I then have to get it to the next one, and the next one, and the next one, and the next one, and I have constant thrust that I can dynamically change to be higher or lower to produce the correct RPM that I'm looking for, with much higher degrees of pressures, much higher degrees of efficiency for burn, and much higher degrees of torque, resultively, in multiple places at once. So, I don't see how this will work. Well, that's the rocket exhaust. The other one's basically do, boom, and then all of them went off. And then do, and then boom, all of them went off. And then do, and boom. And then actually, because it's scavenged and blah, blahs, blah, 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 blahs, blah, blah, blahs, it goes boom, 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 always. One side boom, other side then booms, other side boom, 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 or all sides boom, 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 or constant thrusty rocket. Brrr! Look at my turbine go burry burr. You thought I have too much pressure? I said, nah. You don't know half of it. Let me go pee real quick. Alright, back from all that. So, now you understand why it's like really, really powerful, but also it has a shit ton of RPM, and I can dynamically load it. It's the RPM that scares me. It's very much able to be easily balanced. And it delivers basically all of its work energy that it can, really, to an actual flywheel area with a clutch. And that's another reason why I go, yeah, so people thought that 49cc was something else, and it's not what you thought. You know, it's really the RPM that scares me. It's really just that, though. Like, RPM is deadly. Alright, so it's a flywheel that's traveling extraordinarily fast. The heat's fine, the pressures are fine. That's not the issue. The issue is RPM. RPM is scary. It creates greater and greater degrees of load and material stress and strain. It's balanced, but it doesn't change that. It's like, I'm trying to yank myself apart by doing this. So whenever you load it, it's like, yeah, you're probably not going to load it as hard as you think. Because it's designed to maintain, like a CVT, it's given RPM. That's kind of how I set up my ECU and everything else mechanically. It's like, yeah, no, so like we're trying to bog down, more fuel, air, allow in. What? Meanwhile, you're like, I wanted to travel to 60 fast. And then the RPM goes from like this rather pedantic, like 9K, to like 8,750 maybe. The entire time. So, you know, but that's another reason why I use that kind of technique, because it's super efficient. It's incredibly efficient as a result of that, at maintaining its fuel use and torque. It's like, well, all torque is a given area of leverage over time. That's all work energy is. So it's like, well, now it's like 2.8 feet losses stuff, right? And there's, well, not really 12 of them. There's really only 2 of those. And they're combining their counter rotation into a singular point with really high pressures and resistance to that slowing down. So think of it like I have a lot more weight on the end of that lever that resists you trying to stop me from keeping you doing that given turn. And so 49cc's works just fine for that. I just increase the leverage and I increase the degree of weight. And the mass, consequently, is really rather low compared to most engines. Inline 4s, potato, potato, 2-cylinder, motorcycles, single cylinder, my butt. Inline 3s, why? I weigh less than most of them that would ever try and get near my degree of torque and horsepower. Someone's burping out there. But that being said, while I do weigh less, others can weigh less because of more exotic materials that they use. And they can also just increase the degree of displacement. Mine's this way for a reason, using physics to my advantage to increase degrees of pressure for gas escape velocities and capture of gas escape velocities, I gain much greater amounts of advantage. Acts like much higher pressure, even though it's technically not speaking higher pressure. It's just denser at the end. It's not as hot because I threw in fuel. It's just denser. So, pressure is a weird one. It's a dynamic you have to understand in thermodynamics quite weirdly. Pressure is not equated to heat completely. It's mass at a given heat in a given volume. Okay? So, you can change the mass constant or you can change the heat constant. Mass tends to increase the amount of pressure faster than the amount of heat. Kind of the same thing that kinetic force applied also does. Force, acceleration, mass, square stuff, all that. It's essentially the same fucking equation. Mass, heat, kinetic, this amount of force. And the caveat is volume this size. Good ol', why the hell do you fucking make it harder on yourselves? It doesn't rapidly accelerate at the end. It's gonna go to the next one. Did you not see the other one coming in? It's rotation, remember? Yeah, no, I don't even want to talk to them because it's like, this is the hottest part, right? And it's like, then it goes to a colder, and then a colder, and then a colder, and then a colder, and then it finally the coldest, and then it's like, oh, guess what? Here's some more air, I guess. Right. Well, yeah. Here's some fuel. Burn only around this point in its rotation. And then it's cool on the outside and internally, so, there's that. Heat's very dealt with. Yes, it is, usually. Until you decide to go to a certain cube law problem versus square cube, surface area to volume. Displacement is a shit show. Increasing the volume at which you're doing this with massively increases the likelihood chance of overpressure. 49cc is easy because it's small. It's a small amount. You want to do the liters? Okay, well, I made a 10-liter one in my concept, in my mind, because I can do that. I'm not like other people, apparently. I didn't know other people really genuinely couldn't do that. I'm not like trying to shit on others. I actually just didn't know. I was like, everybody has way better imagination than me. Yeah. Doesn't matter. We'll move on. I made a 10-liter one, though. That was relatively easy. Turns out, though, shocker, I know. It doesn't perform the same way. I had to change the toroidal and the gapping and all the rest of it to make it work in a consistent manner that survives its use. It's still only a foot away. It's just a really big donut now. Right. So the 49cc was already like 500 fucking foot-pounds of torque easily, like at like freaking 3k RPM. So it was really easy to just sort of maintain that RPM and then just dynamically load. Like that was super simple. But then this fucker was like, So I heard you like kind of making a tank fly with practically like no wings. And I was like, I don't know where you heard that, but no. No, no, but you're going to do it though. Why? Because, you know, why not? You have the power. I don't want to do that though. I don't. No. I then proceeded to work on like helicopters for a little while. I was like, let's get ginormous blades. We're gonna get these weird ass fucking looking blades that are curved at the tip, that are kind of like circles. So they curve backwards, and then they have like this flare, you know, like the aileron flare that they do on wings for airplanes to try and stall and be able to get more lift as they land. Yeah, that kind of thing. Similar concept, except they're a bunch of hollow shit. So it's like the leading edge is hollow, and so it bifurcates, and then it's just trying to suck in the air that it has, because it's got like this little curved lip part there. And so as the air gets sucked in, it has like these little overhangs that go into the bottom part of the little flap that's like the aileron. And then it curves backwards towards the center, but then it curves outwards. So it's like, alright, so the outside diameter, very farthest point, is like a little needle. Alright, you know, you see it's got the hole, like a needle, you poke a needle through, threading needle. It curves backwards, and then it curves down. So it's like, it goes like a crescent shape with your hand, and then take that hand and then angle it diagonally. It's like, that's what's going on. And the reason why is because those wingtip vortices are now going to be controlled by doing that a little bit better. Now, the leading edge tip, it goes widest where it's at its closest point to where it's rotating. It then flares outwards, think hourglass. So it goes wide to thin, back down to wide. So it's curving outwards away from the fuselage. Now, that also is being curved, the leading edge is being curved like that crescent again, okay, for your hand. Then the little gaps, these little overhangs, are going to curve in the air as it tries to mush it off to the tips and suck it from the top down. So it's like they're angled such that they're trying to suck that air from the top down. That's what it gets for thrust. So this leading edge is instead going to carve it in to this big flap. It's effectively there, but it's hollow in the sense that it's hollow. But it also happens to have holes that go through it that are air gaps like you could see through. So it's both hollow from the little actual material, but then it also has it such that you could see air through it. See what I'm saying? So it's double hollow, effectively. All the way across the sky! Whoa, whoa! So intense. Anyways, these are teardropped areas on the leading edge, and they're angled inwards to, remember that leading edge is bifurcated, hollow? That is taking air and then having it shoot through the overhang of those little fuckers back into the little hollow nature of where those little flaps are underneath. Alright. What that does is it insanely accelerates the air right there, and then it goes downwards. So like there's already a hole there, and then it's going to suck in that air, and then it's going to ride that boundary layer, because it's creating a boundary layer, down to that main, aileron-like flap that's angling itself to do this. Now, it's much more structurally supported because of the hollow nature, much lighter, and because of the angle, geometrically speaking, that it's at. Remember that little flare out from the fuselage? And it's got little holes there? Well, as the holes have air travel through them, and then the air from the leading edge, and then the air that's coming off, like the wing there, the blade, and then travels downwards much more significantly, and then that air has really been forced to then get sucked into these other little hollow scoop areas in those little gaps as it moves forward, and then shoots out together with the rest of the flow of air and captures it along the entirety of this little bell curve, I guess. It's a bell end sort of ish type of looking flare out. So it's like, remember that flare out, right? Same kind of thing at the very tips of that wing. So like rides outwards just slightly, at the back end of that wing. Like when you see a bird's wings and the feathers bend upwards as its flappy flap fly glide. There are holes there, but then there's this protrusion. So it's like that air got sucked out to go underneath and is pressurized, and that air that's already riding downwards, and I don't want it to change rapidly. I want a little bit of that pressure to go through and then join in, and then the rest of it creates a massive low pressure zone. But now it's much stiffer as it's bent and curved like that. And it's several wings. I use 8 on average. I never use 4. 8's always like the go-to. But that being said, that this is a much lighter blade for what it's worth. It's effectively geometrically shaped to be really stupidly strong at this given type of task. But it also is enormously thin light material. Stiff, really strong for the rotational and lift characteristics, but really thin. So, hits anything, so don't do that. But generally speaking, you should do that anyways. So. From what I understand, But what it means is it curves air inwards as it'll produce that outer, remember that little outer, needle area? Well, that sucks in air from the top from a wider area and then curves it down towards that other area. So it goes from wide back to small, accelerates it, and then back out. And it then uses a lifting body characteristic because the fuselage as a bunch of stalled air underneath it. Yeah, right? You know what that is. Okay, but why? Because it's higher pressure, it's not moving, and it's lower pressure, moving air, it makes more lift. And it's quieter in the cabin, since it doesn't bounce around as much. It's a good thing. You don't want that. That's turbulence, more consistent flow, greater degrees of lift and efficiency for the given rotation, which means this thing rapidly accelerates up. I built it specifically to go really high altitude. Like literally stupidly high altitude. The opposite of what any fucking helicopter will ever do on average, right? Well, I built it for that. And there's a reason for it. Because it's like, remember all those hollow parts? It's not just that it's hollow. Those are my air intakes for this engine that I just talked about. I had it before as a different engine. Well, sticking this fucker on it, I could just attach it horizontally at the top. So it'll suck in air from all of the spinning blades. Huge, wide motherfucker. And it's suck. It's a compressor. Well, I want it to take that air, right? That's a good thing to do. That gives me more lift, lower pressure, starts earlier. I then dump it out the rear and underneath the fuselage. So if you look at the spine of the tail, you'll find that all of that has a bunch of little overhangs, and that's where there are a bunch of little consistent holes that have themselves shaped like a teardrop, starting small, a little wider. Alright? That's to diffuse and allow for that exhaust to come off the tail and join in. It produces more lift, but also underneath the helicopter's fuselage, there's the same thing going on too. Straight down, it's a structural supportive member. You're going to want it anyways. It then diffuses it all throughout the bottom. Makes it a lot colder, and for what it's worth, that column is multiple insulated stuff. So I don't want anyone anywhere near it to break it. So it's hard shit. It's good stuff to have when it's hard like that, so it's not gonna break if you impact. But also it's very well insulated, so you're not gonna burn yourself, which is a good thing. And it's a nice connection point too for you to try and use as a place to hang off or whatever it is. But that diffuses underneath and then creates, while it's hot, a stall. So it's it bunches up a bunch of hot air that's higher pressure. And then has the faster moving cold air travel up around it and then collapse underneath, creating a teardrop shape. So it will even more rapidly accelerate upwards. I then was like, how come helicopter don't move the thingy thing forward? And I looked into vertical takeoff and landing vehicles, and this is stupid. It's why do they do it this way? It doesn't really make much sense. I never really understood it. So then, guess what those helicopter blades turned into? Their wings down. Yeah, you probably guessed. They stall into a single central area, so they slow down, and then as the standard it is, okay, so it's progress is to get up to a certain height, start to allow yourself to travel down, they'll transition to being wings, the nose during that opens up as well, and while I can suck a little bit of air from the wings, not as much as I would want, and so that's my new air intake, and it's a compressor as you travel forward. Nothing changes with the exhaust though. It still exhausts where it exhausts. So, but the hydraulics go over the tail rotor. So now they got the exhaust, the shrouds. So the hydraulic ram will move shrouds over that about halfway, and they're flared out, and then they'll curve back in towards where the tip is for yaw. They also happen to have, with the overhangs for where the exhaust is, little movement, so you get pitch from that, as it's a big wing kind of thing. That's cool. So it's a new type of vertical takeoff and landing. Yes, 10 liter. It's a heavy bitch and a half. I mean it. It's basically an armored tank. I'm not kidding. I was the military might want this. With their Traubum armor stuck onto a helicopter. You have the lightest little butterfly dragonfly wings ever. I'm sure this will work so well for you. I don't know why you would ever want a heavy ass bitch to fly like this, but okay. They could just ever touch the wing, like literally a small wing touch, you're out. And you can't turn like nearly as well as you want to. But it can pull the weight. And it gets to 30,000 feet off that damn engine. Just helicopter. Which is insanely stupid. Like, you don't need that. To be fair, the reason why I did it was purely to show off in that scenario. I was like, guys, look at the advertising. Look, we're so fucking amazing. We are literally the best helicopter ever. Look at our engines. Look at our engine. Look at it. Buy our engines. Buy the engines now. You want a tank that can go to fucking cruising altitude for Boeing 767. You need this in your life. Not even kidding. I made a lighter one that was able to go only slightly higher. Like 45k. It was just stupid. It was like, what is this? Oh, it's lighter, but like really realistic. Like, like as if it was necessary. Look at us, we're so high up. Oh, yeah. But for what it's worth, a lot of people over at Mount Everest ended up using it. It was a good, like, rescue operation vehicle. Like, what are you doing all the way up here? They're used extensively over there. That's what our main market was for, like, mountain rescue operations in high altitude. Constantly. All the time, yeah. These fuckers would not stop. I really kind of got pissed after a while. I was like, you're attempting this because you know you can get rescued and it's safe now. And I hate you. Got a pressurized cabin and all this shit. Fucking pissed all the time. His main use was for that, though. Especially since, like, vertical takeoff and landing turned into, like, well, essentially I can lift a lot of weight. So it's like, so this is the new Airbus of the sky, folks. We're going to get a basically rigid structure by using very pressurized material. You're in a cabin, there's some vacuum all around us. The wings are effectively a vacuum, pressurized material, that are hollow, double, both outside to the outside atmosphere and then internally. Then it turned into like whoosh, 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 bigger blade, blah, blah stuff. And then now we have wings that give better lift, front and rear, which have gimbaling for the tips. So it's like that was our pitch and yaw. That area, that's like that goes up, that goes down, that's this side, that, pitch and yaw now, and then it was like, so, why does it produce, like, this fucking, like, thrust? Like, honestly, like, I want you to understand that I didn't catch what you, because I didn't. Thank you. Thank you. Remember the air intake that I was talking about? And the exhaust? Yeah, I didn't change anything in the exhaust. Right. Oh, yeah. No. No, you didn't. No. But that is an air intake, right? Yeah. Well, I can only take so much of that, right? Yeah. And I don't really need the exhaust. I'm not going to change the ports or anything. Correct. It's a jet engine. So, it goes to, well, it's up here, and then it goes down, and then it goes to a rear. So it's like that intake goes up, the exhaust goes down, cuts off that, because I don't need it anymore, cuts off the exhaust at the bottom, because, again, I don't need it anymore, and then there's a bottom rear fuselage, so it goes to, like, all this exhaust and all the intake, that I don't need, because, like, that's more than I need, you know, then gets sucked in and diverted via the rear. So, like, there's from top down to bottom, and then there's from front down to the bottom, and then there's essentially all of that getting placed into this is an axle, literally, and then there's a faster spinning rotation called, this is a prop, okay, with some stators, and then there's these flare out gimbals for thrust vectoring. Well, they're more like a bell end, because I need it to not hit the fucking tail. It's always annoying, sucker. So this rear part is this is a big to then a small, and then that's where the rotation part is, which then rapidly rotates the prop, and then there are stators after that then go into a smaller little area, because the stators act kind of like a funnel in their own right, but then there's a funnel that they're all traveling towards. So it's like they're just built in. This just uncovers it. So if I'm going to cover up the rear and I'm going to open up this, it's all on a multiple redundant hydraulic fluid ram setup. So if it fails on one, it can be done with another, or another, or another. And if they all fail, well, it turns into back to helicopter. So it's like, nope, it failed. No. Okay. That kind of thing. Instead of bail out, it's like, we're saving this shit. Yeah. So, but that'll open up the rear, and it goes from, like, these are in that funnel, or stators, yes, but they go from a smaller cord to a wider cord that then funnel into completely one little tiny smooth little area that then goes off into the bell end, which has little slats at the end that give us that thrust vectoring, and it can gimbal. Cool stuff. Is it already there? Yeah, well, kind of. Slat goes up, that pushes down and pushes out as a result. So bell end comes out and then clicks in. So it can't be pushed back in. That means I don't burn the tail, which is a good thing. It's kind of pointed downwards to a degree, but you can get it pretty close. Yeah. Bus is effectively the same. Front nose turns into whale mouth. Big liter engine turns into sucky blow fast for rear, which is tail. It kind of curves into a point, but it's not really a full curve in point. You know, it trails off, and then like this trail off then squeezes in, and then you get like a big little area here. Nope, it is not little. No, it is a humongous sized fucking exhaust. You know, it was like, well, I don't need to do it with a tiny little helicopter. This is a bus. Now, granted, it's not going to take up the whole rear, as there's a window there, but still, it's fucking massive. It's just extend out like the bell end, you know, thrust vectory thing, and then it all heads like a massive amount of like these at the top here we got these little suck-in scoops. Same thing with the wings that all travel around the fuselage into this little air intake to slash the prop now, and then we can burn more fuel there if we wanted to, which most of the time we don't need to. Because like the sucking in prop and then that thrust is ridiculously efficient because of how large it is. Captures a lot of the thrust with a good amount of torque vectoring, and then you still have aileron and pitch and yaw control. Whee! But it's a bus. It's just a bus. Yeah. Really? It is just a bus. I'm not kidding. Like, picture your regular metro bus. That's what this is. It's shaped differently, but that's all it is. It's like this one 10-liter is effectively never used for practically anything. So it's like, I need to get people to use this. So this is now like the people carrier bus for airports and stuff. I'm not like even gonna pretend that that really was kind of where it amounted to, because like we ended up getting a lot of people that were really into it and interested in some of my turbine jet engine designs, but they wanted this toroidal engine instead of other like styles of my turbines instead, and I was like, but this really isn't okay. It's not really the same thing, you know. Like those are actual like turbine jet engine prop stuffies, that basically turn into like a much more efficient, far greater thrust characteristic engine. And this one's just like pure, just ridiculous because of RPM alone is insane how balanced it is. Well, the other one had RPM, for what it was worth. Like this one, a good way to put it is like, you know what this engine is, instead of having to take apart a whole bunch of these things, for that engine, and you have to relearn that. Which that one's more turbine because it doesn't have like the same types of blades, or same types of things that a piston engine would have. You know what I mean? Like those are blades. These are just like lumpy, and some things like that. Yeah. So it's not really as worth it, I feel. But then, depending on the person, right? It's like that 1 10-liter is like just a super strong engine that can go really high RPM, like million plus RPM easily. And because it's 10 liters, I can then add in the thermal, photovoltaic, thermal electric generating, and piezo electric generating materials. I'm cooling it anyways because I have wings, so wings are cooling the whole thing. That's surface area stuff, but then like they're hollow anyways. I pump liquid around. That's a radiator sort of situation. You know what I mean? Heats it up, cools it off, depending on where it is. You want that anyways. Greater degrees of lift and thrust characteristics. So, as a result, it turned into, oh yeah, this one singular in the front of the damn nose fuselage turned into, my wings are thrust. The wings do the thrust. I sucky in air and then blow more air out with the wings and make more lifty as a result. And more degrees of effective thrust because of the surface area size of those wings. Now, I never really fucked around with the fuselage much, just for what it's worth. It was never really worth it, but it's like the bus, it's like we got these scoops at the top, and then the wings are kind of like that same thing. And then it's like I can add in more air from that dynamically to either the engine or more specifically just the rear prop. And it's more dense as a result. So it's like it's less dense at top, more dense in this, then I have it accelerated more efficiently thanks to that faster spinning prop, which is actually kind of like 2 props in this instance. So it's like at the engine that's just accelerating and exhausting, right? And so like that goes from a larger chamber and then it speeds up to a smaller, but it's getting sucked up. It's like, that's a certain size diameter. And it's traveling at this given speed, right? This rotation, RPM. Well, this turns into a much bitier, but much faster spinning. So, like, most of it is for the rear to really accelerate it, and then that's where the stator area for that little, funnel, nozzle point is, and then the resultant bell end that's kind of tucked away inside. It still extends a little bit, and then you have the thrust vectoring, but then, like, it's mostly tucked in. So, what was that for, though? I don't even know. Like, I started, like, an airplane company off of that, and then, like, it lifted, like, a lot of the fucking, like, other, cheapness of other airplane company, like, ticket. So it's like it made it really cheap, but it lifted their, like, I'm gonna have to give you quality. And I was like, as if I don't give them quality. You know what I mean? Like, I've got a fucking theater screen front and rear here. They've got internet the entire way through. It's a really nice cabin noise and sound. There's no constant bullshit going on. It's light as fuck. Batteries everywhere. Solar panels on practically everything. It's meant for long hauls, though. That was the main reason why people didn't like it. It was like, so what does this go to? So I'm over here in British Columbia, yeah, and we're going to Australia, and then we're going to go over to New Zealand. Brief layover, really. I'm not even kidding. It was like we touched down only just because. We don't need the fuel. We can literally get to New Zealand. But it was like one of those things where it was just like, oh, we're done. But, that turned into like, well, New Zealand from British Columbia makes sense. But then it's like, hey, yo, Alaska, do you want to go to Australia? Like that kind of area. Like, it's basically a very similar. And you have to remember, like, as the rotation of the Earth, so we can't just, like, fly directly. So it turned into, like, we have this altitude, because we have an enormously high altitude. This is the worst part for, like, most commercials. Like, we are, like, 90 to 100K feet. Like, that's our altitude, cruising altitude. Because all the electricity, so I learned about this, that I love. So it's like, electricity creates ionic wind, yes? Yes, but it's effectively like almost a plasma, right? Yeah. But what if we put a negative electron flow battery in there? Well, that would produce a lot of current. What do you need the current for? Plasma. What if we made really high plasma instead of volts? Well, would that just produce a lot of heat? Yeah. But wait. Just hold on for a second. What if I use that to destabilize any carbon dioxide or bonds from our hydrocarbon use? Why would you want to do that? And then while we did that, upon that disconnection, which creates an electron flow in its own right, we then forcefully made a bunch of mirrors and fiber optics shoehorn all the IR into an inertial confinement laser for this plasma of hydrogen, just all this hydrogen. Then we're going to separate it with this oxygen on the outside. Nitrogen and carbon are going to be separated even further away. Okay. Then we're going to combine the really super hot hydrogen and oxygen, which is still colder, but, and we're going to have them get squeezed into these little multiple tiny little parts and holes, like really hard core squeeze pressure shit. We're going to use the plasma movement to create electromagnetic fields that help me, and like toroidal-like vortexes that spin between each other, that then collapse towards a singular vortex point. And then use other rather standard copper electromagnetics and some really strong lasers from all the surface area. Fiber optics. And charge differences, of course, thanks to the air that we're traveling through, and this shit. And the batteries and the capacitors, of course, helping out the whole thing, and the movement of an engine and the fuel use that's going on. I was then like, yeah, that could work. Let me see here. What if I resonate it just right? Yeah, that would definitely be better. Let me just... Oh... No fusion. There's no fusion going on. It's not hot enough. But I am entangling it together and tunneling it just the right way to have it tunnel together. What did you just say? Yes. They tunnel into each other. This is gonna rock your fucking socks. Watch this. I used a tunneling method of the oxygen into the hydrogen, but they don't like that. They don't want to be stuck together. So they immediately try and fissile, separate. During that separation, which is actually has more energy than the energy I put in, when I properly distance and make sure to separate, right, hydrogen, oxygen, it then smashes themselves to smithereens. And then they want to combine because they're already accelerated so fucking far, and they're now much hotter, and now they're tunneling and so on. I then make hydrogen into a bunch of lithiums that then destabilize back into hydrogen. Oxygen doesn't fuse to anything. It acts as a buffer. I fissile fusioned. So it's like, I didn't ever fusion, but I certainly did fissile. It then absorbs all of that heat kinetic that it tried to have as that spring into continuation of speed. Now, I lost heat energy, but I gained kinetic. Massive kinetic. Relativistic speeds of this now suddenly combining with an electrode that we have to have. So it's like, this turns into, we're just going to fire a bunch of fields that charge field, like the oxygen and hydrogen together, and like they're going to combine exothermically, react, that kind of thing. They're just going to be really hot. Like, they can't actually stabilize together that way, but for a brief period, because of the heat that they're under, not heat, pressure that they're under, and the mass that they're inside of, that acts like that they're in a soda bubble for the nitrogen and carbon that's around them, which will then destabilize and then go. So, like, they're technically, combined in a way, but they're not. So it's like, there's no bonds, right? But briefly, they'll create, like, their own version of carbon, oxygen, and hydrogen and nitrogen put together, and then they explosively decompose all together. Carbon combines with carbon much more quickly, and it cools off because of the way we place it in between the bell end internal diameter and the nitrogen that is protecting the oxygen and hydrogen. So it's like, boom, off into the bell end. Now, it takes a little bit of time to do that, and so we spend a decent amount of fuel getting up to our altitude. That's also why we're very high altitude. That's also why we have so many batteries everywhere, and that's also why we have so much fuel. It's like, we start as a vertical takeoff, and we start traveling forward, and then we start getting that thrust, and then we start getting a really high altitude as we do a nice little corkscrew turn, barrel altitude thing, right? And then we get all the way up to altitude, above where we want to, and then we allow ourselves to drop using that kinetic gravitational energy. We're going to improve the degree of increased pressure that we're trying to get by ramping up rapidly, but not using it for thrust. We're using it for pressure, heat, and electricity as we store some of that electricity as we're going up, and then we use that gravitational potential energy to increase the amount of electricity that we use and pressure that we receive to then create this effect. And then it goes, and then we start going. It sips fuel now. We basically do this with the atmosphere and a little bit of like hydrocarbon use. Once we gain the pressure vessel, it remains there and is very steady. No fusion's ever really occurring. It fizzles, but technically speaking, not really. It was briefly considered, but not honestly, no. But man, did we get some greater degrees of velocity and thrust. We're at like 90% the speed of light. Before we were at like, maybe we were getting Mach 5 velocities. Maybe, right? Now I'm getting like 90% the speed of light. And it explodes outwards. Super fun stuff. It's stupidly fast, but then it's like, I only need to slightly burn fuel. Just a little. It's like a little bit of this goes a long way considering that exponential increase of kinetic gain. Which is another reason why I'm so high altitude, because it's like, we're traveling much faster than you think. Jesus fuck. The standard rule of thumb in this instance is we don't like going above about Mach 12. Our materials are fine at that point. They're cooled, because the engine that we're using active cooling stuff. Then we have a bell end that's also active cooled in its own right. But it's actually not as hot as it would normally be. Like, you're thinking fusion, ridiculousness. No. It's nowhere near that fast. It's just really fast. So it's like, it's slightly actively cooled. It's not really hot enough to be something I would be concerned about. In fact, for what it's worth, it's less heat than a rocket exhaust or a jet engine exhaust. Still hotter than a car exhaust, but still pretty good. Now, that meant that it was like, well, Mach 12, no, it's dangerous, don't. Effectively, you don't move. You just point it, and you're like, we're at this altitude, we're going to point for this curvature and rotation, and this is where we're going to land. And we need to decelerate, so it's like, turn that off, and effectively we glide in for a long time. And we do a nice little barrel, turn thing, only at the very last moment, and then we just do vertical landing. All good to go. Meanwhile, I'm like, so how was the rush there, passengers? We got about like 30 people in there, if I'm being honest. Like, you fit. But I don't honestly do that. I can cram more than that. If I really want to like make it stacked, I can get up to about 100, but I never do it. So often we're only taking about 20 passengers because we like leg room, we like people doing things of any kind. You know what I mean? There's wonderful entertainment. You got internet. So there's that. But, like, what else? There's no in-flight snack. You could pay us, though. We'll give you some food. Got overhead. You know, bins. That's good. You can carry on about 150 pounds of luggage, but then we have to charge you quite a bit if you want to go above that. It's an exponential return thing problem. You know? It's like we don't really have that space, so what the hell are you doing? You know what I mean? It's like there's 25 people here max, really. 20. 20. Fuck off. 20 only. I'm hearing some person go like 30. We can fit into 20. It's 20. Anyways, it's all it's for. It's to be really cool. It's like a nice place. It's just not going to, like, the internals, right? But it's not like opulent plush, the richest of the rich. It was literally like super cheap, really long distance travel. I'm not even kidding. It was like $200. You want to go to fucking Australia? How fast are we gonna get there? Probably about 3 to 6 hours. Does depend. You know, yeah. How much we can maintain? Nah, it's more about like where we're traveling from. There are further places. We were like, what's this all the way over here in the east coast of Canada land? Greenland. Oh yeah, that's right. That's called Greenland. We're like, we're gonna travel over all this stuff. This is literally the fastest, most direct route to Australia. Got there in about 6 hours. It's like the furthest place from Australia, practically. Worked out, though. What do they need it for? It's something to do with the research that they have going on with their colleges and certain companies. It's like $200. Zoop! We had a never-ending flight path to like very far places. It was so cheap. It was just like zoop, 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 zoop. Comes out as like a bunch of graphite in twos and threes, and then like a bunch of like hydrogen and oxygen, so water coming together, or ozone. Ozone was pretty often made too, so, but it's already so high altitude that I just was like, well, that's probably a good thing. They need the ozone up there, you know. Yeah, standard stuff. Mach 12, huh? Yeah, but that's 90% the speed of light. Sipping on fuel, though. Ah! You can already hear them like, it won't work! I know, like, it would work! I just have never thought about this. So cool! Why didn't fuck! I hate you! Don't hate me. Stop doing that. That antagonistic part, I'd end up going after it. It's like, I know it for a fact will work, bro. It's never gonna fuse anything. It'll just incredibly accelerate things. You know, it's like the cold fusion idea that they had back in the day for squeezing with pressure. I'm using acceleration as pressure with a rebound oscillation within given characteristics of densities of plasmas. And a whole bunch of other stuff. It effectively means it does exactly this, but then it just turns it into really high velocities. And I lose a lot of heat as a result. But then it combines, and then it explosively decomposes. So it's like, boom! So it's like it gained back some degree of exothermic, but it's not really exothermic. It's more about just straight acceleration at the end there. I mean, for what it's worth, it actually slows it down, but then it expands it. So it's like it was going like 98% speed of light, and then it slowed down thanks to the explosive decompression to 90. But it's like, yeah, and yet, at the same time, I kind of need that bell indoor. I don't want a laser lightsaber of plasma heading towards somewhere. And then just whatever's in the atmosphere goes boom. So it's like, that'll work fine. That's going to be fine. The wing characteristics were fine, but they were pressurized material for what it's worth. They were a lot heavier but much stronger, built specifically for this, and a very I'm gonna curve all the air as much as I can to a teardrop effectively at the top. It's like there's a bullet nose, and then the wings are centered like a bunch of like wide to small to small to small, so that way like it makes this greatest degree of lift, but then it's the least amount of drag. There's more of a lifting body characteristic bullet that's going through the air. Kind of kite looking thing. Zoom. That's all that was like. I mean, it was literally I could only really kind of get this to work this way, and so to be able to make the freaking kind of thrust that I'm looking for, and like the faster it travels, the easier it becomes, and it's like I need it to basically create bunches of air plugs that then like have a very low heat, but then boundary where the fuselage is, and then it was like I had a high heat, but then high velocity movement of air that would curve around and then collapse just right around where the faster moving velocity bell end thrust was. So it's like I got a little bit of lift, and that's all that's really kind of necessary at that point. And then it was just like, this is just for thrust. Whee! Very low friction. So like the sonic boom that you normally get became not there. The sonic boom actually became a part of the thrust. So it's like that pressure wave, as it's traveling to the faster moving, creates a degree of resistance, and then it travels faster. And so like that sonic boom actually just travels faster to the thrust, and then diffuses, making it more efficient with less drag, along with effectively a bunch of plugs of air that are just tuned right to make it so that way the fuselage doesn't burn and it's actively cooled more or less anyways, and then like all the rest of it is just to make a teardrop bullet shape outside of this little like super high pressure zone, but then it's like slightly less high pressure because I don't really want that much freaking lift. It was like, I don't need it. Stop. All of a sudden, I'm out of the atmosphere again. Oh, fuck. I'm never gonna lie about that. It was just ridiculous how often people would get hurt from that. It's like, woo! Oh, fuck. Oh, shit. Oh, shit. Oh, shit. Oh, shit. And then it stalls. They come back in and the plug of air would be removed that we'd use, and so then it would get hotter, and it's just super dangerous. They'd live, but it would still be fucking so dangerous. So like eventually we had to learn how to tune lift and thrust characteristics. That way you can still get pitch and yaw, but it's effectively a bullet. It's a rocket bullet. We get up to this, and then we go point, and then boom, and then we slow the fuck down by going turn off that, and then whoosh, and then we get bigger wings, and they go up and they spread out, so we have larger wingspan, and then it's all just turning stuff as you catch it, and eventually that allows for you to turn them back into the rotating aspect. So it's like then they are like a Chinook, like they just double helicopter blades. But you have a lot of distance to do that, so. Oh! Yeah, I should have told them about that. They're looking at it in the head thing, whatever connected stuff that is. It's the scoops. Remember I was talking about the scoops at the top of the fuselage? Yeah, kind of a similar process where it's like scoopy, go burr, suck, suck, then thrusty out bottom instead of bell end. Then lifting body, try to work hard as possible. Stall wings start turning as they try and get into their main central point instead of as wings. And then and so like it gets just a little bit, and then that scoop area folds down, and the wings become the compressors. Ah. Oh, it's a nicer transition than you would have believed. Yeah, no, you don't really like fall. You just kind of like hover, slightly slowly fall, and then it catches itself, and it's like, yep, I'm good. For what it's worth, it can land on a regular runway, but it's also like this was for remote places for people to go to. You know, like that's the Greenland thing. That's like the British Columbia. That's like the top of a certain mountain and so on. But it was like, where are you over there? I'll get you there. $200. $200. Take it or leave it. Whoop, zoom. Yeah, fuck. Why are you doing that? It doesn't even experience more than 1G the entire time. I don't know. I just feel like that was scary. Yeah, well, I mean, we're not gonna immediately burst into 12 fucking Mach. Jeez. They're gonna do that to people. That would terrify people. Like, for real, I was like, no. First and foremost, no, 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 no. We're not gonna rocket engine our ass to 12 fucking Mach. We're gonna slowly accelerate at 1G up to 12 Mach and maintain that. And then, of course, that 1G turns into like, well, it's just whatever that is for 1G. So you have 1G horizontal, then 1G down, which is why it's feeling so sluggish. Right? And then it evens out and you get the gravitational 1G versus the accelerational 1G, which really acts kind of like 2G, but then it's not really. No. Anyways. Yeah, no, that was the basics of that as a design, because it was really easy and simple to do. And like, I really do sip on fuel though, but like that's the problem, because it was essentially I'm going so fast that it made no sense to do anything but long distance runs with the fuel I'm using. Yeah. It was like, yeah, no, this is literally, you have to be within this range, otherwise I'm not going to do it, because I would burn so much more fuel than if I were to go this far instead. It just doesn't make sense after a while. It was like, no, no, no. Are we doing short, distance, or are we going to do long distance? Because there's no in between. There's no medium distance here. It was like, I can do vertical takeoff and landing, sure. But, like, yeah, no, unless you're going to travel to, like, the lift, with a wide wingspan versus, like, I'm going to bullet my ass over somewhere, you're not worth it. Like, $200 would never be worth that. You'd be paying me like $5,000 instead to get somewhere within a 200 to 400 mile radius using the helicopter blade, because of like how expensive the fuel really would ultimately end up working out to be to get you there. Versus like, alright, so I'm gonna travel that and this is the real crux. It's like you have a bare minimum 1,500 mile limit that you have to travel, versus like realistically within that 3,300 mile range for that to be really viable, and that would maybe still have you pay 200 for that. Maybe. Like, it really depends on that one from where the start is and everything else. Because that'd be a dynamic, basically. It's just like, well, you're starting from all the way over at this point, and within that 3,300, that's starting to get a little too far. Like, within the 2,000, like, easy all day, that's 200 all time. But 3,300, I can technically get there for that price. And then 1,200's like, just, you're kind of a dick. Like, I'm going to use a lot of fuel at 1,200 because I don't get to maintain nearly as much for that long of a distance, and I don't like that. Which sips fuel, yeah. So, then it's like, past the 3,300, it's like, really, it can't be that far. It has to go to the 5 to 7 and beyond range. Like 12,000 is really like a better sell. Like $200 at 12,000 is way easier to maintain at that fuel use. as a passenger little aircraft thing. But that's the accelerated parameter and decelerated parameters. So, with really high altitude. Yeah, the altitude usually tends to get people. It's a sealed pressurized cabin, so it's really not that big of a deal at all. It's just that people tend to freak once they suddenly realize how fast they're going. Even if they're like 100K, near feet, it's still like they'll pass a passenger airplane looking like it's standing still. Like a Boeing 747, Airbus, whatever, A32, it's just like, look at that small, tiny thing that is slow as fuck. Meanwhile, it's like, yeah, no, yeah, oh yeah. I'm totally gonna look at that. Because it's seriously fast at Mach 12. You're going like so many miles a second. A second. So, like, that's another reason why it's like it accelerates to that point and then it has to decelerate from that point. Which is why it's like, oh yeah, no, I'm burning actually very little fuel, and it ramps itself up using that small amount of maintaining the thing, and then it'll build up as a result of that. Same thing with the air pressure and heat velocities, all that stuff. So, which heat velocity is a weird thing to say because it's like, it's thermal, but it's the fact that it's getting sucked out at first from that, like, given, speed of supersonic flow over it, and then it gets sucked into the air intakes, which also help pressures at that, and then that's a lot of extra heat as well, and it just builds up over time until it eventually just goes really fast. Really stupidly fast. Like, it ramps up. Like, there's a certain cutoff. So around that, like, Mach 3.5 to 4 range, it then starts going and exponentially increasing. It's like, so it's like, we actually can't do that because people get really scared. So, like, we maintain a 1G linear acceleration up to that Mach 12, but you'd be surprised how fast you can get to Mach 12 with a 1G acceleration burn. Like, exceedingly fast. So, it's one of the reasons why it was like, well, sure, I guess, if you want to. It's that 7,000 really. 5,000 is like a bare minimum, but even then, it's like, I can still swing it, but if I had to do that every time, I wouldn't. You know what I mean? It's a every once in a while sort of deal. Like, that 7K is like that real bare minimum, and then, like, really it's from 7K to that, like, 9, that's like not a butter zone, but like that's the kind of, like, if I'm doing that more consistently, than even, and so it's like really that 8 to about 12 is the butter zone. Which means halfway around the world. Yeah, yeah, yeah. No, whole thing, yeah. It's the most efficient when it's like 8 to 12. So just that little range. So, yeah, you end up realizing pretty quickly that like fuel use and everything else becomes like a fucking shit show to deal with. It's like I have to land vertically each and every, and I think this is a much higher altitude than you really think it is. Landing is a bitch to deal with. Gliding in is also a bitch to deal with. Then vertical takeoff and landing, which uses a lot of fuel. Instead of like, I'm not really ever allowed because of like this fucking aircraft being what it is to ever really land on certain, most truthfully, um, air runways, the runways for airports. So it's like a shit show in a lot of aspects, but then it still sustained like a good business model. It's like, oh, I want to travel as cheaply as possible to this. It's like I have basically nothing but a fuck ton of passengers always wanting that. You know what I mean? It's like, no, I'm definitely gonna go travel to this place because it's that cheap. I didn't really want to go to France today, but you know what? France is not that bad. Let's go to France today. What are you doing? It's like, here, drop you off at the whatever fucking place that needs to check your passport shit. And I'm like, yeet, bye. We're supposed to check it there, but, for what it's worth, we checked it on the way. But they're going to have to do it, and that's your whatever the fuck that is. Don't become like the Tom Hanks guy. Hope you're good. That's generally what I say pretty consistently because almost everybody's going to a new country for so cheap. I'm like, do you actually know how expensive it becomes? You have to like deal with all of that, and you basically just kind of can only stay there for a little while. It's like, no, I'm going to go over there for a day today. I'm like, day? Today? A day? Are you sure? And yet they're willing to pay $400 there and back. It's so fucking cheap. I'm going to do it for a day or two, and it's like I'm back. I'm like, yeah, that's true. I mean, you want to stay there for 3 fucking months, that's a real expensive shit show. Meanwhile, the people that are there that live there, you guys need to leave. There's nothing but tourists everywhere. What is this? More money for you, I think. Point is, I got a lot of money. Like, I always had profit. It was just brute force, just like large amounts. Like you can get margins based upon the amount that you're selling. And like that's basically what I'm doing. It's like I'm gonna be selling so many people back and forth. And so I'm always getting a margin of profit that pays all the employees, all the fees, all the rest of it. And fuel basically becomes like, well, guess what? I make my own fuel. Ha ha ha. After I got enough profit, it was like, yeah, what is that? Jet engine fuel? That's stupid. I'm going to use my fuel. And it works! Meanwhile, I'm selling so much fuel to so many people. It's so annoying. It's like, what is that? I'm now a waste treatment facility that sells fuel? How come you guys don't make your own fuel? I don't know. I want the fuel for myself. Yeah, but,
Yeah, it's true. I get a lot more money off of that. I'm not even kidding. To a certain point, it was just like, well, this is just going to be the fuel I sell to like cars and then like aircraft, and then I'll just maintain all of what I need all the time. No, I did try and do that for a while, but it's, airships and blimps are real difficult to make work when you're traveling so fast. It's like, holy shit, dear God. Oh God. Maybe I'll see a blur over there. Okay, here comes the wake. Oh Lord, no! You weren't supposed to be at 100 fucking thousand feet up in the air, man. No, I know, I get that, but still. You know we had to dodge our ass, right? This is like a fucking couple 100 miles back, too. I barely got out of the way. Golly. Fucking suck. Air traffic control. Holy fuck. Oh God, air traffic control. These guys are trying to be the best. These fuckers. Dedicated personnel just for the speed of land. Oh my goodness. It was fun times. For what it's worth. Really? Yeah, no, we stopped doing it after a bit because it was like, well, this is essentially a space plane at this fucking point. Why am I even in the damn atmosphere? It's not even a joke. I was like, oh, no, let's just cut fuel costs here real fast. And, fuck the vertical takeoff and landing. Yeah, why are we doing that? And then it's like, oh, I can finally land now. Meanwhile, here's 5,000 people. Then I even crammed into my ginormous fucking skyscraper-sized fucking space plane. Got the huge wings. Yeah, it was the wings and the fuselage. So it's like, that's the thrust. Boom. Huh? Anyways, of course my dog decides to tip out all of my coffee on my nice, recently washed sheets. Thanks, Phaser. Anyways, there's a nice little coffee stain for that. But anyways, yeah, no, it's like, all right, so we're in space, right? Yeah. But also not really. I mean, we're out of the zone of the atmosphere. Is like massive, like ball, but this isn't very ball massive. No, I don't know. Doesn't matter. Point is, we're outside of the very farthest reaches of our atmosphere, but then we're like skimming it essentially. You know what I mean? Like, we'll go out and then we curve back in because we use gravitational, and then we'll use like a degree of that extra speed to maintain a increased degree of efficiency for our fuel use. We also happen to still have some degree of lift from that, which is good. So that's big surface area stuff. That's why the wings still come out when we're out of the atmosphere. It's like, what are we doing? Like, you wouldn't understand. Whee! So I never really feel fully like going out into space, that kind of thing. But anyways, it turns into like, it's much easier to go and glide back down now. And so it turns into like a little bit of fuel. We get up there, and then we'll skip over, and then we'll hop back down. And now that's why it's 5,000 motherfuckers that are crammed into this thing, right? No! It's a pretty big fucking engine. You mean fuselage? Interrupter? Yes, shut up. Fucking damn bastards. The fuselage. It's quite large, but also the wings are as well. But if you ever know about like wingspan stuff, and it's like you have one that's slightly smaller right behind it, or pretty close to, then it curves. You know what I mean? Like you get more lift. It acts like a much wider wing. It's kind of basically doing that. It's like this is the wingspan. I just have multiple wings doing this, and then they fold inwards. Yeah. That way, it's like here's a nice teardrop shape, and then it's like then they go back out. As we accelerate, and then it's like we're gonna get out. And that's a great amount of lift for lifting body, because we don't want a lot of like actual, you know, drag. But then this becomes much easier to propel out of the atmosphere and then maintain a consistent little continuation out of the atmosphere as a skip. And we don't need to really go quite as quickly, because that's not what we're really here for. We're not here to make an orbit, so we're here to go back up and out and then up and back out and just give thrust to it, right? Then we land wherever the fuck we would need to land, because that's just a big long glide thing. It's like and then we land. Why do you always spin? Yeah, it's a whole thing. You'd be surprised how fast you can go. It's pretty intense. Like, to get out there, it's really hard to slow down doing that. So, especially with 5,000 people in a massive skyscraper, you know what I mean? It's like, it's a lot of mass to slow down, and so it's really just better to, like, allow for yourself to drop, but maintain speed, and then glide after, like, using lifting body, all the lift, effectively, that happens to help create. And so if you just curve inward correctly, you always set up for, in the wind kind of thing, to land very safely and evenly. You experience 1G throughout the entire time, which is nice. Most passengers tend to like that. But yeah, that was what turned Greenland into one hell of a tourist spot for all of the during the northern hemisphere's winter duration, or for New Zealand and Australia to just take a chill pill off in Greenland. Because again, it was like $200 to go to Greenland. We were taking 5,000 with us. No, 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 no. Meanwhile, I'm like, it's nice, guys. It's a nice place these days. Greenland. The fucking glacier? There's an island? The island glacier? Yeah, it's hot. You want it. Oh, yeah, it's hot. Oh, yeah, okay. Numb. Meanwhile, I'm racking up money after money after money after money. I basically used no fuel to do it compared to my last one. It's just ridiculous. But then it was like, oh, guess what? We're a cargo ship. I'm like, yeah, I don't care. I don't wanna at all. Not even in the slightest amount. Leave me alone. Then they paid me a couple of $1 billion. And then they signed a contract for a few $100 billion more. I was like, well, I guess. I guess we'll try it. No, whole thing. We were cheaper than ships to move things around. So there was that. China got real friendly with everywhere in the world. America did too. A lot of places did, truthfully. No kidding. It was like, well, this is the real the reason why we have five. Okay, wait. What is it? Shit. It was only supposed to be passenger. I know. So it's like, well, this is the maximum blah blah blahs for efficiency wings and seas. fuel UC woosies. And we got there to like, so everything now uses us to fucking put every. I hate this thing. Really? Yeah, no, it's not even a joke. I just got pissed. I was like, this was just to like connect people to around the world, to experience new culture, and to allow for people to have an easier time getting somewhere else and out of danger and so on. So then it turned into everybody's consumerizing everything and all the things. Just consumer capital, consumer capitalism, consumer capitalism, capitalism, consumer. I hate this. I'm participating in the very thing I hate. And then a bunch of planes just magically were not there. And the company was not. I had a few trillion in the bank and I was like, yeet! Have fun! They went back to using boats and shit and they were all angry with me and I was like, yeah, I don't really care. I then made a couple of rockets. That was fun for a bit. I then made the equivalent of the Bioshock Infinite verse floating airship sky city, and then it turned into a whole entire country as I was allowed to do that. And then I was like, I am the ruler of the skies! I am! Not even a joke. I'm genuinely not kidding. I am the totalitarian benevolent dictator with the rainbow fascists that all socialism anarchistically democratize all of their stuff. Wait, really? Oh yeah, no, I've already talked about it, and the whole hybrid government thing went on for a while, but it's all that. But now it's in the sky! And it's basically impossible to fall off, except for the edge of the country, so don't do that. Meanwhile, it's like, do you want some shade over there? We'll move over there if you want some shade. You're gonna have to pay us some money for that shade, though. Meanwhile, the money in question. Look at all these cool resources! Yay! We're off, like, fucking colonizing the moon. Making all of our own fuel. It's fucking awesome. Getting all this collected dust from the atmosphere. Just making our own fucking Earth that floats. Farming. Doing the aeroponics. You mean hydroponics? No, because it's aero. Because we're in the air. What is the fuck? The point? I don't want to make a much denser material called Earth. Except for where I need it. Which isn't going to be there because it's suspension stuff. I want the version of aeroponics where I use liquid styles of Earth, which is hydro, but no. You see what I mean? It's not, because I use air, and then I lightly mist what is necessary because it's already going to be there. It's like, it's super cold. How the fuck did you keep the? Oh right, yeah, no, you would. It needs to be buoyant, bro. So it's not gonna just be able to be a rigid structure and shit. Needs to have the whole fucking dome thing going on and shit. Not to mention I have a bunch of wind blockers and then air funneled through to increase pressures, and this is heating and this is cooling and stirring and then thrust and lots of, buoyancy with aerodynamic stuffs, a whole bunch of shit, really. Meanwhile, that bubble is really good because it's like, look at all these static charge field differences and electromagnetic, and then we're going to use a bunch of reflected lighties sort of stuffs that basically go, begone charged particles and UV radiation. We are going to destructively interfere with you and make ourselves get natural light that we wish to have. We are currently 1 billion strong. There's a country that's about half the size of the United States of America, the west half. We look down upon you constantly and observe your movements. As you do it with us in your satellites, as we use satellites to watch your satellites, and you watching your satellites. Meanwhile, it's like, your satellites only see a blurry image. Meanwhile, me, look at you. This is clear and crisp as all could ever be clear and crisp. You're not allowed to observe us. We are fully allowed to observe you. Suck it. What are you going to do? Stop us? We'll fall on you and kill many, many millions of people. What you gonna do, huh? Huh? What? Huh? Meanwhile, me. Oh, look, the ocean's cooling. There's more glaciers happening. We're precipitating out large amounts of cloud seeding. We're controlling weather events. This is nice. I'm liking this. What are you gonna do? Stop us from looking at you? This is a national security problem! I guess we'll just move somewhere else. You didn't need that rainfall or any of that shade. No! God damn it, come back here. I need that tremendously right now. That's what I figured. Meanwhile, I'm in a tentative alignment with practically everyone. So what you got over there? You gonna try and nuke us? Oh, you think I'm so smart. But I'm not smart enough to do that, eh? Look at this ocean problem. I just want to test some stuff. I wonder if we can direct some energy with some light from the half the United States sized area of collection. It's nice though, it's nice this place. The steam, I like it. It's good. It's nice and humid. I needed the water anyways. You know what I mean? We're running all the water. That's what it was. This nice buoyancy. This is water energy capture. We're just gonna drain it on. What you got over there? You need a lake filled? I've got a nice lake to fill. Jesus fuck! Stop fucking around. But you need this water. Yeah, no, that's fair. It's a lot of water. God. It's nice cooling rain for you guys during the summer, huh? You guys want some light energy? I got some microwaves for you if you want it. We don't want no, we want those microwaves. As long as you promise not to hurt us with them. Oh yeah, that's fine. Whoa. Yeah, yeah, fun stuff, you know. We were like, we are the people that help all the people. Do 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 do. And yes, we do accept people coming in for what it's worth. But then again, we use airships mostly. You know, I love it when they're like, this F-22 Raptor is so insanely important, and I'm like, brrr, did fucking no. The light death ray that beseeches you compels you to meltify and blow the fuck up. Archimedes? Nah, this is Lemke here. Oh god! Exactly right. It's like, yeah, no, I built this with my trillions. I had a lot of fuel saved up, all this other fucking, like, great technology along the way that I started making and doing this with. They were all like, build us train tracks! I was like, nah, I'm not gonna do that. I'm gonna make myself an air fucking, like, country. I'm just gonna travel around and watch all the people below. Oh, you do allow for light to come through. Oh, yes, yes, for sure. No, yeah, no, we are. We don't need all that light. What are you kidding me? Come on. It's a lot of light. No, we're not doing that. Meanwhile, I'm like, look at all the electricity. Do 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 do. Water collection, humidity, electricity, electron flow electricity, static charge electricity for like the lightnings. There's a lot of that going on. It's very light too. Oh, you have no idea. I went all out on the strongest material with the lightest that I could make it. And it is extraordinarily lightning. Wow, is it strong. I don't know if I can break it apart. Truthfully, I've tried. I've used fusion stuff. That breaks it apart. But then I don't know of another way outside of fissile and fusion material. No, fissile, it survives. It's irradiated, but it survived. There's like a big gold, like, yeah, no, super hard. Like rain, water, all that's never really seemingly gonna fucking fall off of this fucker. And if it does, it's effectively elemental composition at that point. It repairs itself. Yeah, using the dust and everything, so it's like it'll attach using, because of static charge stuff, multiple ionic bonds until eventually it gets to a covalent with the way it's set up. So it's an organic thing at this kind of like, it's synthetic, but it acts like an organic machine where it repairs itself. It senses for us. It stores. It eats our waste, changes it to electricity and fuel and food for us. We have lakes. We've got lots of great, hills and valleys. We've got our own weather systems and patterns. We are bubbled in some areas and not in others. Or half bubble, we allow airflow, but it's captured. It allows for consistent rainfall and weather patterns and cooling and heating and energy creation. It's a real nice thing, That's what you decide to do with your trillions. Yeah, I made a whole country that they can't fuck with. It weighs more than enough to destroy like the entire half of the United States. It would kill them all. They were fucked the moment I started. They're like, it's in the Pacific Ocean, and it's his stuff, and he's allowed to. And then turned into, it's the half of the United States of America. Just floating up there, just doing its thing. Much higher than the Mount Everest. You know what I mean? It's about 65 feet, 65K feet. At its lowest. Its highest, it's about 100K. So, and that's where you would view it from below up. It doesn't go above 150K though, so that's why peaks, valleys, all that. Storage of energy. Yep. Water runoff. Yep. Thrust. Thrust! Using big ol' massive heat pumps from the light and, Stirling effects. Lots of other stuff. I had a lot of electricity that I capture, like a fuck ton. Like, for what it's worth, I have many exawatts of hours that I can dump into anything I want at any given time. Yeah, no, I love doing it for like the simple fact that if I happen to slightly like brrr, the water and make it like evaporate really fast, but not like death laser, that kind of thing, then it's like, oh, then that'll evaporate up. We'll capture that. That's thrust that we use, and then we'll capture it as it'll curve in like the wingtip vortices, and then it filters through as well a little bit, and we capture that water. It wicks up to the top, it freezes, and then depending on how we decide to melt it, we can then allow for rainfall, and it's less dense, yeah. And now that becomes a part of buoyancy factors when it's certain levels of thickness and weight. Oh, spread out over certain areas, yeah. Cool. Meanwhile, the albedo factor go brrr, or lensing factor go brrr. Gets real good at making lenses and various other things to manipulate and constructively and destructively interfere with light. Great. You could destroy our entire, anything. Yes, well, you didn't stop me from building it, so. I'm not going to disagree. I'm really not, you know what I mean? But it's also dynamic and, really realistically, the same for that hybrid government is don't fucking try and invade us, which now made it a lot harder. Don't fuck around with our internet, because our internet's a big deal. So, that's the general gist of that, which I talked about. And I will fully take your shit. I will literally destroy your entire country. Oh, yeah, no. There's a lot of active defense system networks. Let's put it that way. ICBMs are so fast. Boom. What ICBM? Why did you try and set that off in your country? It was a failure. Oh, was it? Was it? My country is glazed with plasma and very high heat. Here's some rainfall. Fuck. We'll just add the rainfall and some light in the right places. There's a lot of explosive potential there. Light and water, Ah! Gravity batteries at that point, yeah. Yeah, I mean, it was going to do it anyway, so, yeah. You don't have any special, rare earth metals and stuff. Oh, we don't? Yo! Anybody gonna stop me from doing this? It's my own land anyways. I bought it a while back. Yeah, well... Can you not... This mountain belongs to me. He picked up a mountain, dude! Yes. I mean, how far does that go? Can I get it to magma? I guess, yeah. Brrr. I'm just gonna use this magma and mountain. I'm gonna dump off old shit. What do you want over there? Is this some mineral shit you want? I don't need it. There you go. I got some stockpiles of resources you find appealing. And more than enough elements for me to do all the things I want. I'm gonna fuse a bunch of shit together up here from hydrogens and heliums. I'm just gonna make any kind of fucking element I want by fusing and fissiling it. Is that a problem over there? That ginormous area of land I bought that I literally carved until it was in the lava stage? Out of the ground for you guys? You wouldn't happen to have some issues with that, would you? No! It's great energy for me, really. I'm just gonna fucking sell you electricity from that. If we just keep mining with this constant inflow of water, using the steam to break it down, make electricity, and then I'll just have like this mineral and that thing and whatever else I want and or need. Our fucking heat battery, bitch! I'm doing some planet cracking over here. Dead Space is probably not really all that cracked up to be what it is, considering I'm definitely better than them at this, as I actually did it and don't have any fucking like weird ass bullshit zombie things. It powers the entirety of the western half of the United States of America. Clean energy for all of you. Good shit, though, you know? Fuck power delivery, you fucker! Yeah, fuck you. I can undercut your market so easily, I don't even have to try. By the way, you got a bunch of internet as well. My power lines all have internet attached to them. You already talked about that several times on YouTube, didn't you? Yep. God damn it. Is there anything other than that? No, I basically just did that. Really? Yeah. I mean, we turned it into a spacecraft after a point. And then we just kind of like left when there was a big asteroid that was a dwarf planet and a protostar heading towards us. And then like all of our country was fine. And whatever they did was whatever they did. We then proceeded to destroy all of our stuff. And any information of what all our stuff was. Yeah, that kind of thing. Just straight delete. But, you know, you guys remember, so it's fine. You'll get it done. So, you know. Why would you fucking dick? Meanwhile, us just flying away. See you later, fuckers! Come on, we gotta get you guys off the moon colony. You guys gonna join us? Hell yeah! Woohoo! Do. Big old spaceship just fucking going for it. Fully self-fucking like propelling and sustaining and all the rest of it. From just the heat alone, and we have fusion and fissile and all the rest of that. Constant faster than light travel that we're using that I talked about on my YouTube channel too. For thrust. You're like, boy. Went over to a new supercluster and then found a new planet. It was fun times over there. Colonized a new planet. It's fun stuff. I don't know what happened to them, truthfully. I never bothered to check. For what I understand, they were all relying on us to fucking get them out of this situation, because nobody had really developed much, because they all just used my technology. I was like, use my technology without my permission. See what happens with my ginormous fucking huge floating country. Try me. Meanwhile, we left, so it's like, well, I guess you'll fucking remember somehow, and you'll get her done. That's basically the half of that. The other half turned into, and we're infatuated, blah, 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 blah. We left one place in the most remote place in the Pacific Ocean possible. That is effectively an escape room. That has a bunch of puzzles and riddles and all the rest that you have to solve. And it'll give you all of the information of how we made everything. All of it. And all the instructions to do it. All of it. It is constructed out of something that would, genuinely speaking here, survive the impact. To prove that, I laser bombed the shit out of it, and also plasma fusion shot at it, and then dropped several fusion bombs on the fucker. I then showcased it was in no way radioactive, and still holding firm. And all of the information, should you try and tamper with it, deletes itself. And then it bombs. It goes neutron. It goes supernova. Like, it literally novas itself. Like neutron bomb supernova stuff. Huge gamma ray burst. So it's like, have fun! I hope you remembered and you were paying attention. And you weren't jealous and you listened to all my YouTube videos and all the rest of it. Nah, it's not even a joke. We left, that was the only thing left. We destroyed all of the manufacturing that make our stuff. And we really made sure people were never going to use it. Even close to similar stuff. It was like, you want electricity, you want food, do you want to live? Don't take our shit. Pretty simple stuff, you know, yeah. Like, it's one man stuff. Yeah, exactly, don't take it. They tried to for a while. I'm like, you do realize that we can see you like 5 miles into the fucking crust of the earth, y'all retards. I was having a blast on that one. I was like, did a little boom, boom, doom, boom, psh, psh. They're like, you're not! Okay, sure. You want electricity again, right? Yeah, that'd be nice. Oh yeah? You gonna stop using my stuff? Because these fuckers made it so all of you have to suffer this shit. You fucks. I don't know what you're talking. I don't. You know, look, man, it wasn't. They're dead. So, you know, along with all of the other people around them. But it's highly specifically surgically targeted. That's kind of like the bomb laser stuff. But, you know, they often control degrees of your power and, water and all that. People that thought that this would be a reasonable choice to do somehow. Just listen to not taking the man's intellectual property and creative ideas. Fucking stop it. Meanwhile, look at this! The entirety of California doesn't have towns or cities anymore. Oh. Yeah. It's like, you guys understand though, right? When they all collectively decided to do this and we went through the court system to try and get them to stop, and then we removed them from doing it. We let you understand that we're serious and we're not going to care what you think. We were civil, you made it so we became uncivil about it. That one was fun. Really? Yeah, most of the world kind of got the fucking hint. Don't take the guy's shit. America backed down hard. It's literally like, try and launch something. I know where all of your stupid little subs are, I'll tell everyone. You think those nukes are gonna fucking work? I'm not gonna let that happen. Yeah, you wanna shoot at us? Come on, man. Please make it so we have some degree of defense. No. It's basically like, I'm really big and I'm gonna tower over you. Fucking stop trying to bully me. I said these are the boundaries and you're gonna follow them, you little fucking fuck up. Other countries could honestly, they understood. And it's like, we were able to work with them. We used our stuff with them. They were nice people. And for what it's worth, we have allies. We have a country. They want to be a part of our country. It all worked. America was a bunch of fucking dumbasses that thought that this was something I was going to allow for. I don't care if you think that I was not in the right. You manifest destiny most of your original America. You then proceeded to bully and constantly overwhelm to get your way. Nobody really gives a shit about you, America. I provide basically everything for everyone. The simple rule was, don't use my shit, ever. Don't try and attack us. Don't try and fuck with us online. That's mine. And now if you ask for permission, we'll just give our stuff to you, and then we will maintain it and have full control over it. You will not be allowed to ever have anyone work on it that is outside of us and our country. Now you can understand why all the things that we were very open about, right? So it's a massive tease for most. It's like, guess what? Here's exactly how to do this. You can't use it at all. Otherwise, we kill you. But here's how you can do it. Then we removed all of it. We put one place in the worst, most remote place we could ever put it. And it is some fucking shitty puzzles. Like, for once, I was really happy to make a 32-page, 3-point font password that you had to decryptively add into a computer to then start an actual beginning to it. No, you don't have it immediately. No, you have to go through several puzzles before it will print out. Not stored. The data is never there. None of it is seen or used. Only if you do the right sequence does anything even exist. And do anything. It also kills you with gas. It melts your insides, but makes you have a very pleasant experience while you undergo that. Orgasmic and euphoric as you die and melt internally. It also makes you stupider as it goes through that. So then it sucks it out, and then the bodies are there, and the next persons can go in. Bare minimum is 3 people. Technically speaking, you can get away with 1, but I would really not recommend it. And there's a time limit on every single one of these things. A really hardcore time limit. You don't get it done, you die. So, the best and brightest have never made it past 3 stages, which is essentially they got the computer to start, which is what the password effectively allows for. All of it's an insanely indestructible, very unable to be scanned or used or known in any indirect method at all setup. I mean, like, the computer is not a computer. There's no way to get the information because it doesn't exist there until it existed there. What the fuck? There's no, I can scan it with lasers or fields or any of that. Because of the materials and the active defense. And once you even try, you're dead. And the whole thing, gamma ray supernova neutron bombs. Which, for instance, we let people understand that that would be the case, as we had a small little tiny purse-sized suitcase that we then detonated behind the moon, just slightly, so that way the gamma ray didn't kill you, and the nova didn't really cause any problems for any of you, and the neutrons mostly didn't hit you, because they went around the Earth with the angle that they were kind of going through. Yeah, with a degree of like neutrino pressure dynamics that would allow for it to try and basically skirt away and go off another direction. Still, it's a higher amount of neutron, but nothing so extreme that anyone would even have an increased likelihood of cancer. So we're like, here you go! That's what that does. Don't fuck with it. Now, the reason why we put it in the most remote place possible was really just to make it even worse for people. Because for what it was worth, most intelligent scientific, engineering, all of it, the backgrounds, were with us on our floating country and the moon base as well, or moon country colonization. Oh, most. I mean most, too. Not all. We have a whole personality assessment and all this other stuff, but yeah, no, most of that. So, but that doesn't mean that there aren't a damn good amount there. And, for what it's worth, they're paid or whatever what that is. But now you understand why it was like, well, your personalities are really not going to gel well. And you really have to work together, and truthfully, the bare minimum would be about 30 people that you need in that place to get everything done as fast as possible, correctly as possible, to then actually not die. And if you try and tamper with anything, I'm not trying to scan the data or anything, but like fuck it up. So this one I loved. You do the wrong sequence, you die. You know what I mean? Like, oh, you did this and you tried to do, and then it's like, then you died. You break this, guess what? You die and has to replace it. Sort of a situation and thing. It's a whole series of things that you really have to do correctly. Because you die if you don't. But I figured since, that's less people, right? That you're going to have to try and get off the planet. And now you understand why it's like rich people just yeeted themselves off. See what I'm saying? It's like I've got my fucking basic bitch rocket and so on. Yeah, no, a lot of it rapidly changed. You'd be surprised how fast people are like, no, I'm not accepting that. What, are you kidding me? No. Fuck yourself. I'm not building that. You need us to build that. You're rich, sure, but you're not this person that's going to be able to build it. Not to mention, we want to save this many people, or I want to save and so on. Right, plants, animals, seeds, all that. Mm-hmm. Who has the best technology to do it? Me. Well, we know about your stuff. Oh, absolutely, yeah. Do you know how to make that? No, not in the slightest. See? Whole thing. We try and corner you. Active defense systems, bro. You're never cornering me. Right. So that's sort of really super annoying. To some. I mean, we're over 1 billion strong on the floating goddamn country. So, when it comes down to the moon colony, that was over another 1 billion. And we just left. So it was like, yeah, I don't really care. I've got more than enough here. It's good to go. It's another reason why I just didn't care. It's like, dude, do you really think that you're going to be able to stop us? How? We have our own lasers. Yes, active defense laser systems also do exist. I mean, we play cat and mouse for a little bit. Yeah, but, Yours is the entire thing. Ours is wherever we can try and set it up at. Yeah. I see you trying to do that. Brrr. Oh, I get it now, yeah. A lot of that turns into that. It's really quite funny, though. Because it's like, we're not willing to do anything unless you provoke us. Which that's considered provoking. So, then we just left. It was like, look, you guys didn't want us to be a part of your shit and all that, and we just left. Like the countries that were a part of us on land, hey, come on up. We left. We left. Literally, we didn't do anything. We just left. We left one area that has all the information left, and that's it. We deleted all the other stuff and straight out and destroyed all other bits that might have remained in any other types where they observed from afar anything. And we destroyed all equipment and or took with us that equipment. I see. Well, that's something. Thanks, dude. Yeah. No. It was good. It was good. You didn't want it anyways. That's what you kept saying to us. Wait, what? No, but I do, though. You don't understand, though. I'm gonna need that. Right now, actually. Nope. Nope. Sorry. Really? No, not in the slightest. I'm not sorry. It's a fake sorry. It's all just fake sorry. And then we left. Yeah, we just left. It was literally like we were there, and then they saw us disappear. Like, now you see me, now you don't. Levels of shit. We were already over there. Just fucking going like, new colony, new fucking planet to colonize. Freedom in paradise, freedom in paradise, freedom in paradise. Meanwhile, them, yeah! They had years to get themselves out, right? Couple decades at most. Like, I wouldn't even give it 3. But sure, I suppose. It was literally like that fucking problematic for them. It was like, if you don't already have all that we had, I really doubt that you're going to do it anytime soon. Because it takes a long time to make rockets. Let alone make them the old way that you make them. So it was like, yeah, sure, you can do it. I mean, like, all other things pushed aside, you're not going to don't look up. You're going to get all of this done, right? You're going to fucking really research, develop, get really far and faster. If you want to do the thing in the most remote fucking place in the Pacific Ocean, you can, I suppose. You'll probably just die. Yeah, no, because if you send information out, so this is the thing, a person outside team can ultimately talk to the people inside. But any information from them cannot be left, and it cannot be taken outside of that. What? What does that mean? It means you can put someone new in from the outside that was looking in and observing them and trying to help them. But the moment they write, score, talk, they can't talk and discuss. They have to go in before those new people come in. No information from inside gets out. That's effectively what I'm trying to tell you. They can't leave anything behind, otherwise they immediately die there. It's scrubbed and made to not exist. Any information inside gets replaced. It's all set up to immediately and impeccably be exactingly the same. It'll open the doors and you can try again with someone new. Because the only reason why they opened and nobody came out is because people died. They all died. For its worth, the bodies can be thrown in, and you get a little bit of extra time because it'll give it energy. Now, it doesn't need it. Ever. At all. It doesn't. But, you can get 30 seconds more. That might mean you live. That's it. There's no one in there. There's no other person. There's nothing like that. And it will kill you once the time limit's up. You can't break it. I guarantee that. It's the equivalent of an emperor back in the day needing to untie some knots. Instead of doing it properly, he tried to cut it. And I went, sure, I guess, but there was one thread that would have unraveled it all. But nice going, I suppose. You fucking brute force monkey. You missed the point. Three minimum, you can get away with one. You just have to sign that you have understood that you're at a massive disadvantage. No, it checks. Yeah, it's a thing. All the other ones don't have to do it, though. Fair is fair. You agreed. It's unfair, I didn't have as many. It's a nice little psychological trick. It's like, deal with it, bitch. Why wouldn't we just make other things? Sure, go for it. I'm not gonna fuck around. We already left. You might even come to the same conclusion. Maybe. Right. It's a fucking joke. It's a trap. We're wasting time on that. We could just make our own. Yeah, that's what it's for, basically. You will never pass that fucker. I made sure of it. No. I made sure of that. There isn't enough time, and every single bit of the information is removed. There's no way to slowly plunk away at it, and you definitely are dead. And you're quite remote, so like you're probably not getting anywhere. What else is there to do around here except for this fucking thing? Big old cruise ship comes in with really smart people that think they can fucking do this. Look at these fucking retards. They tried, like, honestly, we set it up before all of that, we left kind of stuff. So it's like, look at these stupid dumbasses. They really aren't just gonna make their own shit? Why not? What is this about? Makes no sense. I honestly don't know. It was like, you have rocket designs. Like, you can just decide to brute force all of this and get it done. Why don't you do that? Just fucking pull all your resources. Remember when I asked, are you going to do that? Companies often don't work together. Countries certainly don't seem to as much as you want them to. People often as well, when they're very anxious, don't. And Don't Look Up was very, very, very similar to how it is people really react in the real world. There were a lot of people that plunked the hell away behind any and all that bullshit and just fucking tried to brute force any and all rocket and anything that they could get their hands on fast as possible. At least that's what we were looking at as we left. Plunk, plunk, plunk. Just fucking get. Now we need to live. We can't just get off the fucking planet. Remember, guys? Oh, yeah, no, that's true. Yeah, right, yeah. Like, you don't have any of your biological immortality like us. No. Okay, wait a second. Man, you need to be big, dude. That way you can keep pumping generations through to live. You know, when you really scale the problem up, it gets real different. They don't have any of their faster than light tech like us. So, they didn't know where we went for what it was worth. So, you know. I didn't really care. Like, I know that some people would be like, no, you're supposed to care or something, right? No, I'm not gonna care. I didn't care. Like, honestly, like, my predictions were most, if not all, of humanity died on that fucking planet. Like, they never got out. I shouldn't be so candid and cavalier and, you know, just laughing about it. But it was funny, because it was like, dude, come the fuck on. Really? You couldn't just build some shit together? You had 30 fucking years. Yeah. But you had some decades here to do shit. You could have gotten everyone off that planet. You could have all together pulled like the big International Space Station with all of your different little modules and figured shit out. You didn't do that. Like, you see what I'm saying? Like, that's what would bother me. It's like, why didn't you do that? Why wouldn't you do that? Why would you not do that? What is this? Why don't they do this? What else in the hell matters on your planet? It's going to be destroyed. Completely, 100% meltified. Whoopie fucking do, bro. Oh, we're gonna destroy the atmosphere. I don't care. Brrr. Anything and everything, let's go. See what I'm saying? But no. They're going after this fucking, like, total and every way trap. It's a trap, man. It's like there's no way to solve it. Genuinely. It does have that information. If you do solve it, you will 100% get that information. All good to go. But you also go through the process of making some of the stuff while you do it. Or at least you're supposed to. Nobody's ever gotten past the computer. And it's still, like, I started this whole idea back when I was homeless in Massachusetts. Pittsburgh. Pittsfield. Not Pittsburgh. Right. Pittsfield. Yeah. So it's like, that's when I did that. It's like, this is the escape room setup. And it's like, it's refined itself over time, but it's like, yeah, here you go. You'll have all of the information. You'll have made a good majority of these things. You can't leave, though, for what it's worth. Like, it won't give you that. But, like, you can now then make big scale stuff, and you know implicitly how to do it, alongside of having all of the instructions and all the material, all the things. Everything. All of it. But it's a pretty long, if you did it perfectly, it would be a 36-hour escape room. The longest duration is 2 weeks and 2 hours. It's not going to give you food, by the way. So, like, have fun. Water? Nope. Better go in there if you expect it. With that. Which, by the way, it won't, the gas, seep into that food or water. So that's good. But for what it's worth, you're probably going to die. Like, no one's ever gotten past the computer. Like, 3 screens is the max that things have ever gotten to. There's many more past that. It's like, it's a trap, man. It's like, I don't care how smart you think you are or your ego could be or how many people. No. Go do the right thing. Start building now. Start developing and building again. And go do that.
now. Don't get that shit. It's a trap. The only thing that's trying to get that is people that would genuinely not understand that part and believe that they're better than ultimately this plain, simple logic of progress over time. Progress over time. That's it. Do the work. Build the shit. Get going. Get her done. It's the stupidest thing, but that's another reason why I like the smart people that kind of like, fuck. I'm not. No, I'm gonna do this. Let's go. I'm not traveling that far to that fucking remote ass fucking. No. Not to mention all the other stuff that we need resources and all that. It doesn't matter if they get it, fine. But whatever. Do this. Why aren't you doing that? Where are you going? A lot of people fell into that hole. It's a huge trap and hole, man. It's like you never understand that it's like you're not gonna get it. But it's like that was the last message that he ever sent out to all of the people. It was like, so this is there, but it's a trap. It's meant to showcase that your ego and your belief of your intellect is stupid. The plain, simple answer is always the same. Just do the thing. Just get it going. Just keep going. Just fucking run. Keep going. Just build. Just make them. Go. Literally that. Progress over time. If you get anywhere in that development stage, you know what I mean? Creativity, this, that, anything, some sparks of imagination, use it. Go. Don't do the dumb thing and try to take something else from someone else. Do the work. You're going to want that if you ever want to survive out there anyways. You're going to need to learn how to use your brain. Put it up to snuff by continuing to reiterate and go. You're going to want to survive. You're not going to want to fucking like just whatever, right? You know what I mean? You don't have the time. See what I'm saying? Like, you really don't have the time to escape if you want to go after that. Just go. Just go. That's all it was. Ever. That's basically what the whole message boiled down into. This is just like, fucking build the conventional, start the fucking, like, we're gonna just push whatever fuel and whatever else we can get and go, and then like reiterate and this, that, any and all. Let's try, let's do, all of us work. Let's get you fucking caught up on how this works, that works, go. And it's like, this is it. If you're behind, we can't do it. You're gonna have to figure it out. Peace. And that was it. For what it's worth, I don't know if anyone ever did it. I actually don't. We'd already left. Really? Yeah, we had already left. I mean that. Like, we had already left. We were already doing our own thing. Alright, so the second part of this is the guitars. Alright, so I saw Electro Boom today, one of his videos he released. And then it was like, right, so like he's got this plug, plugged into what looks like a guitar, and I'm like, there's a way to make that happen. Like, sure, it's a technicality-wise live wire, but it's like it still has electromagnetic fields, and if I put them throughout the guitar body in the right way, and like for pickups, and then I allow for it to match field changes. So this, as it goes up to down, and then like there's changes based upon how it moves the electromagnetic field and creates more resistance or less resistance here, field effects as transistors, and throughout the body of the guitar. Okay, as it moves, it can create like a theremin, but it's guitar, right? Pick, that kind of thing. And it's like, well, as it moves from one area to another, as it oscillates, it then creates a very unique sound or sine wave changes. Still have to plug it in. And yeah, no, guess what? Yeah, you're going to have to use very insulative gloves and picks. Because this thing's a live actual wire. Don't ever touch it. Still works like a guitar. It sounds amazing, like a guitar theremin harmonic accordion thing, like our harmonica accordion thing. Super cool stuff, man. You know, because like then you can use your gloves as you move them around. You don't ever have to touch, but then like you can pick it, you know, and then move your hand around. And it's like as you do that, it's like, oh yeah, you get a lot of fucking sound out of that. So it's like super cool in that aspect that it's like, it's a live wire. Playing with something that will immediately kill me. If I fucking fuck around with this. Good stuff. I was like, how do I fucking make this not that, though? And then it turned into like, well, there's a separatory wire that's connected to that wire, right? Then like, you know, like piano string to a soundboard. You know, bang, bang, bang kind of thing. So like you pick that, and then that's the wire that it moves as a resonance, and it's still connected, but it has insulative, right? And so it's separated, you know? And then it then means that you can do all of the cool pheromonic, harmonica, accordion-like electric guitar. You know, you can even get super big bass out of it. So it's like, yo! Because it's like an amplifier. So it's like, it's going to drain and collapse that into a different electromagnetic field, like wire wraps, field effect, transisting, meaning allowed to go through more, versus less. That's the field effect, right? Less resistance versus more resistance. You know what I mean? And instead it wraps that energy that it's trying to use as resistance into the next wire. Alright, so it's like it's oscillating and it moves the resonance of the AC line that you're using, and you know, it basically just, that's why it's a whole bunch of different styles of like sine waves all put together, and you can hear it, you know, like it's real fucking cool, you know. Good way to put it is like and stuff like that. I got a whole bunch together. Because I even have the you do all of them together. You gotta get real good with your hands though. And hey, men and women out there, hey, sexy hand stuff. You know what I'm saying? Yeah, for what it's worth, that's the end of the whole, like, you know, scenario, future history thing that was supposed to be a thing, but then because free will and, you know, me being effectively harmed and traumatized and all that, as I was throughout my life, never really happened, so, or at least I don't think so. Remains to be seen kind of stuff, but there's that. That's another reason why it's like, I have all of this technology, I'm not just impressively intelligent. It also is something I developed as a result, you know, of all that. So it's just sort of built into me. Brute force stuff. Anyways, but it's really good stuff. You should try it. In no way. You should help me be able to build it. And now you only need a plug. And now the whole thing can make that sound. Because that's another reason why it's like, well, okay, so it's like the AC, like that diaphragm. It's like that's the circuit. So you're playing the circuit that's connected to the amplifier. Like you run the electricity through the amplifier to that diaphragm speaker of any kind. Instead of using that as the amplifier, that kind of thing. You know? That's done. I'm still trying to get to that 420 mark here. You guys want to talk about something real fast? I got some water. I had coffee today. 30 grams to a liter. It's pretty good. Yeah, normally it's 60, but this is a light roast, so I suppose maybe it was that. All right, 420. Bye.